then your theta 2 will be less than 0. You can consider this that's also there. Like in case of the right-handed medium, the lens will be when there is a lens application can be done, but particularly you can consider there is a convergent source, and the source can be and the signal electromagnetic wave can be propagated in different types of right-handed medium, but there will be no option to further convert the signal. But here the left-handed medium, if you use it in a lens, you can found that based on the use of a left-handed medium in between the two right-handed medium, we can make a lens, a perfect lens, etc. So therefore, you can consider there are huge number of numerous applications are there for right-handed or left-handed metamaterials. What are those applications? You can consider these absorbers, antenna miniature arrangement, super lens imaging, cloakings, models which is used particularly in reduction scattering RCS, the tunable metamaterial, energy harvesting you can use, or RFID. And so there are so many numerous applications are there. So let's describe about the some of those conventional commercial applications or the well-known applications of this metamaterial in this webinar. First, we are going to talk about the microwave absorbers based on the metamaterials. So, what is the microwave absorbers? As the name suggests, exhibiting the absorption at the microwave frequencies, either in the single band or in the multiple. Single band structure is giving the single band absorber, multi-band absorption is multi-band absorber is giving. How the microwave absorber is resulted? So, when this considered this is a microwave absorber, when there is a incident wave is impinging on the structure, so there will be some transmitted wave and there will be some reflected signal. Now, when this reflected and transmitted signal both have been reduced, or when this both have been minimized simultaneously, then the absorptivity will be maximum. So basically, the absorptivity will be complement of this reflected and the transmitted signal. Now, how we are going to reduce this transmitted as well as the reflected signal? One option is that we can put there is a ground plane at the back side, and if we put the ground plane at the back side, then there will be complete metal lamination and there will be no transmission. So only it will be left with the absorption and reflection. Now, how we are going to reduce the reflection? We can go for impedance matching at the top surface. That means we can match the input impedance of the structure with the free space impedance, and the reflection coefficient can be minimum or can be reduced to 0. And when the reflection coefficient will be reduced to 0 or very minimum, so then the absorption coefficient will be becoming maximum. So that means you can consider for a filter structure which you know in the commercial way. So there either we need to minimize the either reflection transmission, but for an absorber structure we need to minimize both the transmission as well as the reflection coefficient for getting maximum absorption. So how is the disadvantage of the conventional absorber structures? Mostly the conventional absorber structures like the Salisbury screen, which are generally narrow band applications. The Salisbury screen has been developed for the lambda by 4 with a quarter wavelength distance, and it is giving the absorption only at a particular frequency where the distance is behaving as a lambda by 4. After that, it has been improved to geometry layer, where the thickness has been improved to get a bandwidth enhanced absorber. But both the cases, Salisbury and geometry layer, the bandwidth is much improved. So then the people has moved to the commercial pyramidal absorber, where the bandwidth is very large by using the graded impedance matching concept. But the problem here is that the thickness is approximately of the order of lambda due to this graded impedance matching concept. And the second point is the fragile this type of carbonyl powder based absorber, and hence it is little bit less durable. So then the people has come up with the metamaterial absorber where almost all the above disadvantage can be reduced significantly. How? That metamaterial absorber structures ultra thin, the thickness is almost of the order of lambda by 20 to lambda by 50 based on the frequency. It can be made scalable, that means the structures can be made from microwave to terahertz even in the optical frequency, while keeping the concept you can only need to make the geometry difference or you need to change the metamaterial specification. But the concept you can make, underlying concept can be made constant, and in the microwave structure particularly, it can be done in a very low cost way by using the PCB etching. So therefore, we can go for the low cost commercial metamaterial absorber can be designed in a microwave applications. How it has been started? In Landy and their group has first started the metamaterial absorber in 2008. At that time, what they have done that they have put a electric resonance surface, whereas a cut wire at the bottom surface, and these two geometry has simultaneously been optimized to reduce the reflection and the transmission coefficient at the same time. So when we are reducing the reflection and transmission coefficient simultaneously, absorption will be obtained maximum at 11.48 meters. The structure not only simulated, it has also been experimentally verified. But the problem is that this type of we need to optimize both minimize both reflection and the transmission coefficient. So, but if we put the ground plane at the back side, then we only need to minimize the transmission coefficient. So subsequently, all the structures have been recently developed in the metamaterial based absorber cases. These structures they put the ground plane at the back side. So therefore, your reflection coefficient will be need to minimize, while its transmission coefficient is always 0. So then this type of structures here in 2010 or subsequently, where your absorption coefficient is maximum based on the minimum reflection coefficient. So then from single band absorber, it goes to the dual band absorber by using the scaling. Then we move to the bandwidth enhanced absorber. Bandwidth enhanced absorber, either we can use the scaling part or we can go for the stacking. So here we can use the multi-layer geometry to increase the bandwidth slightly. But then we can move from narrow band absorber to we can go for the broadband absorber. How we are going to broadband absorbers? In broadband absorber, we can use the finite resistance effect. Particularly in the previous cases, if you see, we have only used the metal pattern at the top side. This metal pattern is made from the copper or this type of high conductivity material, so the ohmic loss will be very low. So we have to introduce some type of high loss in the geometry to make it a broadband absorber. So how to introduce a high loss in the geometry? The one option is that we can use it either through the dielectric loss, but that is also have some limitation. Another option is that we have to give or we have to incorporate some finite ohmic loss at the top surface. How to introduce this finite impedance matching or how to introduce this finite resistance effect at the top surface? For this, we need to use some either type of the lump resistor or resistive sheet or the resistive pent. So this type of effect or particular this type of mechanisms are mostly used to introduce the high amount of resistance in the top surface. Already top surface has some conductive effect either from inductance and capacitance. So basically this resistance and conductance effect or reactance effect both together is giving some impedance matching at the top surface. In addition, high resistance is producing by this lump resistor or resistive sheet or resistive pent, which is giving the broadband absorber. How this lump resistor is behaving? This lump resistor means that the structure we are considering the metallic pattern in the top surface for the metallic initial geometries are of the order of lambda by 4 to lambda by 6 distance of unit cell, and in that case we are putting the lump resistor, we have to solder this lump resistor in the geometry. Lump resistors have large ohmic loss, and based on this large ohmic loss, these structures are absorbing the wave for a wide absorption bandwidth and thus giving the broadband absorber. So the structure has an advantage that it is almost low costing because this lump resistor have very small cost of the order of less than 1 rupees. And but the problem is that if you do not have any automated soldering machine, you have to solder manually all these lump resistors. So that is the fabrication tolerance will be very high, or it will be prone to the experimental error. And second point is the time. If you consider that there are large periodic structures and there are thousands of lump resistors are there, it will take huge amount of time to solder all these lump resistors. So then second option is the resistive sheet. So what is the do with the resistive sheet? There are different types of ITO like indium tin oxide based resistive sheet, where the resistivity can be determined by like from the company or industry standard. And now by using some different laser etching machine or micro machining technique, we can pattern this type of geometry in the resistive sheet to make this a metamaterial based broadband absorber. The advantage is that it has highly accurate because you are using the laser to etching the unwanted part. The disadvantage is that you need to use the laser or micro machining technique, which is very costly. So therefore, if you have this laser etching machine, you can use resistive sheet. You have to go for the lump resistor. But then there is an optimal technique which you can consider the resistive paint, where generally people are using the resistive one type of paint which is a large conductivity, and we can use the average cost spin painting technique to paint it on the structures. So the cost is average, accuracy is moderate based on how precision you are using those things. And then we are going for the resistive paint. So this type of broadband absorbers, by different application you can determine those things. Note that those are the defined applications. The basic concept is same, that you need to use the lump resistor or the resistive effect from the top surface, or impedance matching is coming from the bottom layer and the top layer reactive impedance. So this is one concept we are considering the broadband absorber in the metamaterial. Then we coming from the other concept of the metamaterial application in the micro devices. One is the micro filters we can consider. What do you mean by the filter? So in the filter is that these micro filters, particularly based on the metamaterial, they are slightly different from the normal conventional filter. These filters are known as the special filter. Why special filter? Because their geometry response not only depend on the shape but also their response, that means frequency response, depend on the polarization as well as incident angle. So how the incident wave is impinging on the structure, its polarization angle, its angle incidence, TE polarization or TM polarization depends on that its frequency changes. And how this frequency has been determined based on the unit cell geometry, this periodic unit cell, the metallic pattern, etc. are overall determining the resonance frequency as well bandwidth of this filter geometry. So how? So let's consider one basic example. So if there is this type of gap is there, so this gray color is the metal and this yellow color is the gap. So if the electric field is present in between this gap, so there and the current is flowing along the electric field, so then this gap will provide one capacitance. And on the other side, if electric field is present along the length of the metallic induct line and the current is flowing along this metallic line, so then this metallic line will effectively exhibit one inductance. So if we combine these two together, so that means if we give the capacitive response in one geometry and if we give the inductive y bit and the, on the one layer of the another dielectric layer, so the dielectric layer top surface this is giving the capacitive response, bottom layer is giving the inductive response. Now if we combine them together, it will give the band pass filter. And in this type of cases, we can use for metamaterial based microwave filters. But what are the applications of that? There are so many applications are there for these metamaterial based filters. Particularly, you can use it for the miniaturization piece. Why miniaturization is required? Because this type of periodic structure, they have the unit cell geometry. Single unit cell is not going to work. You have to put this multiple number of unit cell geometries in a particular place. But if this multiple number of unit cell geometry you are going to put in a particular place, so then this space is limited. So if we put more and more number of unit cells, then this place will behave as a close to the infinite geometry. So therefore, if you make the geometry size smaller, so more number of unit cells can be fitted in that limited size, and it will be mimicking the ideal metamaterial based filter. Second option is that the gating lobes will be appear delayed. These gating lobes actually deteriorate the structures, particularly the higher angular region. So if the gating lobe will appear in the higher frequency or it will appear late compared to the operating frequency range, then angular stability will be increased significantly. How it can be used or how you can go for the miniaturization? The different techniques are there for using for the miniaturization. One option you can use is the fractal geometry. You can consider increase the order of the fractal from k equal to 0 to 1, 2, etc. So then the frequency has been reduced from 16 to 8 gigahertz. So here you see the unit cell geometry is constant size, but the frequency has been reduced. That means your electrical size has been reduced. So your electrical size has been reduced. That means your miniaturization response have been improved. There are other ways also, like we can use the convoluted geometry. This is the slot square loop geometry. But if we use the similar slot geometry by using the convolution, the frequency will be reduced or your miniaturization has been improved. Further, here the convolution has been improved in the third places. So there are another option, you can use the SIW technique or you can use the lump capacitor. SIW will give some additional metallic capacitors, or the lump capacitor will also give the lump capacitor additional capacitance to give some this type of additional capacitance, or which is going to be used some reduced in the improved in the miniaturization. So next we go for the another application of the metamaterial based filter, which is high selectivity. Particularly in many cases we need that where the selectivity is highly required. We need very small bandwidth of geometry where the particularly only 100 megahertz is only required, or is required to be passed, or maybe required to be reflected back. So for those cases also filters can be used. As for example, we can go for different technique. One is the aperture coupled resonators. So there are some aperture are there in between, and the resonators top and bottom layer they are getting coupled between these two resonators. So by controlling the geometry dimensions, we can control the transmission nulls across the two sides of this band pass response, and we can make this band pass response very much selective as desired. There is second option is that we can use the SIW based multilayer. This substrate integrated via based concept we can use, and by using the cascading technique or by using the number of cross or number of slots, we can improve the high selectivity. Okay. There are other option is that we can go for the multilayer geometry. Particularly in the multilayer geometry also we can use that number of geometries, and both the all this number of geometries can be go for the multi-order geometry with a high selectivity. So these are different types of the metamaterial based filters by using for different applications like filter applications, or you can consider miniaturization application. So then there is another application is the microwave polarizers. So what is the polarizer? So let's consider there is a square loop. So this is simple square loop, and this square loop is symmetrical. Whether you give the electric field in the horizontal direction or in the vertical direction, the response will give similar. So if you consider that there is no metal ground at the back side, so this type of geometry will give a band stop response. So let's consider this geometry, and if you simulate this geometry, it is found this geometry is giving a band stop response at 10 gigahertz. And when it doesn't matter if the electric field is vertical or horizontal, the structure will always give the same response. So that means it is a polarization insensitive geometry. But what will happen? Then we are going to check that whether the electric field incident on this structure, whether it is getting polarized or not. When we check this polarization, it is found that the co-polarization response is giving the ideal one, but the cross-polarization response is very small, close to minus 40 dB. So that means the wave which is incident either vertically or horizontally, after interacting with the structure, its polarization doesn't change at all. So that means this structure is not at all a polarizer, it is simply a band stop filter. So then how we are going to make a structure polarizer, or how the polarizer is behaving? So if we just put a simple slot in this geometry in a diagonal way, so what is happening is found the same geometry putting a diagonal slot, then what is happening? Its band stop response not only get deteriorated, but also its cross polarization response have been improved significantly from minus 40 dB to minus 10 dB. Now you see here the structure not only gives some co-polarization response, but also the structure is giving some cross polarization response. That means the electromagnetic wave, when it is coming and interacting with this wave, this after interaction, some part is getting polarized to other polarization and some part is remaining intact in the same polarization. So this structure is behaving as a polarizer or polarizing converter. There you can consider the electric field is coming in vertical polarization, and after interacting, it is moving to the either horizontal polarization, or maybe it can keep with some amount will be vertical polarized also. So this is, you can consider a polarizer structures also. The polarizer structure has also several applications which have been previously like used by the Faraday's rotator or bifringing rotator, etc. But those conventional polarizers are mostly bulky and they heavyweight, etc. So those are not like suitable for a practical applications. So then comes the metamaterial based or FSC based polarizer. And those polarizing rotators are two types you can consider. One is the transmission type polarizer, another one is the reflection type polarizer. What do you mean by the transmission type polarizer? This polarization, as the name suggests, the electric field is coming or incident on a structure, and after incident on the structure, it is getting transmitted in the opposite polarization direction. So if it is coming in the vertical polarization, after interacting with the structure, the transmitted wave will be polarized in the horizontal direction. So let's consider this was initial geometry in a periodic structure. So there, if you found here at around 11 to 11.5 gigahertz, its cross polarization response is very high, close to 0 dB. So that means whatever the incident wave is coming, everything is being transmitted to the opposite polarization direction, whereas its co-polarization response will be very small. So this is almost a transmitted type polarizer. What is the next type? It is the reflection type polarizer. And what is happening? That there is the back side, there is a ground plane admitted. And when the back side there is a ground plane, nothing will be reflected, everything will be transmitted, nothing will be transmitted, everything will be reflected in the first medium. So there, if the incident wave after interacting with this reflected type polarization rotator changes its polarization of the reflected wave, so then it is known as the reflective polarization rotator. So let's consider this type of geometry. Here, electric field incident on the x direction or y direction, it doesn't matter. The wave will be reflected back with the cross polarization. So if you see from this graph, if it is coming in the YY direction or the XX direction, the co-polarization response will be very, very small. Whereas wave is incident in the X direction, reflect in the Y direction, this response will be very high, or vice versa. Okay. So this type of things are there, you can find in the metamaterial based or FSC based polarizers. So then whether there are other applications are there, yes, there are other applications also there in the metamaterial, particularly in the antenna geometries also. So how the applications can be found or described? Note that the antennas are aperiodic structures. Except the liquid antenna, where the many universals are there, mostly antennas are like microstrip patch antenna, or there are the other MIMO antennas, or the monopole antenna, dipole antennas, horn antennas, everything is the aperiodic structures. But the metamaterial concept is a periodic geometry concept. You are using this metamaterial concept, that means that where the universal geometry is very, very smaller than lambda by 4 or lambda by 6. So these concepts are there in the metamaterial. So then how this metamaterial concept can be utilized in the antenna? So therefore you cannot tell that the metamaterial concept cannot be directly used in the antenna, Rather, we can use the metamaterial type of universal geometry we can incorporate in antennas to improve some of the performance characteristics of the antenna. So those antennas are known as the metamaterial inspired antennas. So instead of telling metamaterial antenna, it's better to tell as the metamaterial inspired antennas, where you are using the concept of the metamaterial in the antenna instead of using the direct metamaterial images. So what is the advantage? So there are different types of advantages are coming from this cases, like particular radiation characteristics can be there. So there is a bandwidth enhancement will be there, or maybe their gain can be improved, antenna size can be miniaturized. You can use the CRLS transmission line or compactness or fabricated cavity, AMC, and so on. So there are earlier development initially in the 2002, and at that time there is Elfridris, there is Kalos, and those professors, eminent professors, that introduced the CRLS transmission line, that means composite right-handed, left-handed transmission line approach in the metamaterial. Where they have introduced some additional transmission line concept along with the conventional transmission line concept to improve the metamaterial performance. And slowly in 2003, and then there is other approaches are there, and in this way it is continuously getting up. So there are several structures have been developed based on the metamaterial antennas or the CRLS transmission line based antennas. Particularly, there is by using the CRLS transmission line, there is some additional peaks can be derived. Like if we consider the simple, this is the monopole antenna. This is monopole antenna when the CRLS transmission line based on the metamaterial concept has been incorporated. There are two additional dual band have been developed. So basically, the structure from single band it has been moved to the triple band structure. Similarly, here also this structure, here also metamaterial concept has been used, the via based geometry, and here also from single band it has been moved to the dual band geometry using the serialized transmission line concept. So there are other inspired concepts are also there, like we can go for the zeroth order resonance to improve its compactness. We can go for that the interdigital capacitor and complementary resonating concept we can use also. We can go for the complementary split resonator concept also. They are using the defected ground. In many cases, either the structure is like becoming compact, or its gain have been improved particularly, or its bandwidth has been improved, or sometimes this concept has been used to improve its reconfigurable options also. So in this way, metamaterial concept has been used in antennas for improving its performance in different ways. And then we can come for the other applications. So there are so many applications are there, and many of applications, although most of these applications are in that research oriented, but now people are coming in the commercial cases. So now recently there is some university in the Hong Kong who are like recently generated about that metamaterial based acoustic absorber, or the metamaterial geometries are used to absorb the sound wave of the of the system, sound system, etc. So let's consider the other best of the applications. If you can consider 3D printed broadband absorbers. So what are the broadband absorbers? The normal broadband absorbers is giving the very large amount of the broadband absorbers, particularly where the micro absorption is very high. But here, if you use the three-dimensional printing technology, what is happening? That geometry will be perforated. And if the geometry is perforated, then your weight will be very much reduced, the volume will be very much reduced, and subsequently your structure will be giving the similar performance at the expense of less amount of volume. So this type of three-dimensional printing technology can be used in the broadband absorbers. Then we can go for the filter concept. So this is another concept where you can use the metamaterial concept. This filter is a combination of the filter plus antenna, where this antenna we are using the filter and to selectively receive the signal coming from other side, or selectively transmit the signal radiating from the antenna. So in this way, we can improving the frequency agility of an antenna by using this filter concept. Then we can use the absorber concept, where we can combine the absorber plus filter. The structure will behave as an absorber for some particular frequency range, while it's behaving the filter for other particular frequency range. So there is some other cases of dynamic of metamaterial using origami technique, but origami means which is known as a paper folding technique or the reconfigural technique. When this is the plain fold paper, so then it is behaving as one frequency, but when you using the origami concept, then the structure will behave as some other frequency will behave, or it will behave as an absorber, or maybe other structure of filter geometry, or for other frequency cases. So this is the origami concept we can use. Then there is a liquid crystal based on the tunable absorber, another reconfigurable absorber concept. Or using the tunable liquid crystal, and then by using or biasing, we can control the liquid crystal tunability, and we can make a tunable absorber. And the last one is the graphene-based absorbers, where by controlling the graphene resistivity, graphene reactance part, etc., we can make a tunable absorber using this metamaterial concept. So in this way, there are several mathematical applications are there, and I hope that many more applications are going to come in the coming days. So let's complete this lecture now. Please let me know if you have any doubts. I'm trying to solve.
Thank you, sir. That was a very informative talk. We have some doubts in the chat box. I will read them to you. So the first doubt is from the audience. The first doubt is, are metamaterial absorbers applicable only in microwave frequencies, or is it applicable to higher frequencies as well?
First one is that metamaterial absorber, the concept of the metamaterial can be applicable to any frequency. It is microwave, terahertz, or infrared, or even in the visible frequencies also. So I am talking here the metamaterial absorbers in microwave frequencies, but the concept has already been well developed, experimentally verified, demonstrated in terahertz frequency as well as infrared frequencies also. So there are eminent professionals like Professor Anant Ramakrishnan in IIT Kanpur, who has already demonstrated metamaterial absorber in infrared frequency ranges.
Okay, sir. So the next question is, are there any resistive inks or paints commercially available?
Yes, there are various resistive inks and paints commercially available. If you go for the resistive paints, particularly there is few companies are there in India. I forgot those names, but those companies, there are one company. So initially we have, so in IIT Kanpur, we used to purchase those inks particularly from Germany, known as the Y-Shield. So this is the Y-Shield company, but the resistive inks are there. So from the we generally purchase those things, and there are tech institute. There is one company is there, Pune-based company. From there also you can determine, you can purchase the silver conductive paste, dielectric paste, resistive paste, etc. In India also there are commercially available paste are there, so you can purchase anywhere. So in India also companies are there, outside abroad also companies are there.
Okay, sir. The next question is, are there provisions in commercial EM softwares to extract mu and epsilon as function of frequency, or only experimental methods? So it's regarding how to calculate the mu and epsilon in EM softwares.
As far as my information, there will be no direct way to determine those values, like extract the mu and epsilon from the commercial sector. But what we used to do is that we simulate the structure in the software, and then we extract the S11 and S21, that means your reflection coefficient, transmission coefficient, and then we put it in the Smith formula, or there are some other formulas to extract this mu and epsilon. Now, HFSS or CST have the commercial sectors. Now, if you wish, the person wish, he can put those commercial equations. They can use, or they can put those equations in the software also, and they can extract that mu and epsilon directly in the software. It is either the function of the frequency, that those things, this mathematical problem, it is either you can put it directly in the software, or you can use MATLAB code to extract this mu and epsilon.
Okay, sir, that will be a good answer. The next question is, please suggest the fabrication technique that can be used to fabricate metamaterial absorber for high frequency like 60 to 70 gigahertz.
For 60 to 70 gigahertz, your structure units are geometry will be very small, particularly of the order of the track length will be coming of the order of micron sometimes, or of the order of very, very small, like 0.1 millimeter, less than 0.1 millimeter, 0.01 millimeter. So either you have the experimental, like there is commercial fabrication techniques are there, particularly if you can consider there is some ISRO or DRDO, some SAMIR, this type of fabrication high-end workshop are there, company organizations there where this type of fabrications are available. But I am little bit doubtful that commercially in India around the 60 to 70 gigahertz fabrication is little bit difficult. Particularly you can consider the 0.01 millimeter track length or 0.05 millimeter track length. Mostly there is a PCP Power is the company, which is Ahmedabad based company, which is the low cost fabrication type of company. So there also the minimum track length is 0.1 millimeter. With the 0.1 millimeter, we can go up to 30 gigahertz or 40 gigahertz, but up to 70 gigahertz, it will be little bit difficult.
Okay, sir. So we'll have 4 more questions. So
yeah, let me
okay.
say something, Shapnil.
Okay, sir.
Yeah, so I think it was a
Thank you,
wonderful
sir.
talk.
Is there
And
any?
we can have interaction with Dr. Ghosh later on also,
Okay, sir.
because he is very close to us on various fronts. So you will get enough opportunities to talk to him. It was a very good talk. And so I congratulate on behalf of all the chapters and APS Kerala for this wonderful initiative, and special thanks to Dr. Ghosh for accepting this one and having this talk over here. Thank you very much. So, yeah.
Thank you. I think Professor Antar is here, and there are so many dignitaries
Good morning,
here.
good morning, sir. It's very early morning, and you have been so generous. You have connected on two back-to-back days, sir.
Good evening. That's fine. Thanks. I'm really glad to join in, and I just caught the tail end of the interesting talk, and it's very interesting. And I see that Debdeep is up too, and so is Jawad.
Yeah.
Yeah.
Good morning. Good morning, Professor. Good morning.
Yeah.
Good morning,
Good
Chinmoy.
morning,
Good morning,
Jawad,
Debdeep.
sir.
Good morning, sir.
Good morning, Saptarshi Ghosh, Dr. Ghosh. Thank you very much. I too, joined at the fag end of your talk. Thank you so much.
Yeah, same here. I also joined at the fag end of the talk. I think 10 to 15 minutes back I joined just when he was. So good evening, Saptarshi. Good evening,
Yeah.
Dr. Saha. Yes.
Yeah,
I
good.
take this opportunity to thank Professor Antar sir once more. We are really privileged to have President here, President-elect and President 2021 with us, no 2 consecutive days. Thank you very much, sir.
It's my pleasure. And I really thank you all for going through this effort and organizing all of this for the benefits of the young future researchers and for the benefit of the society. So thank you. Thank you all.
Yes, sir. Actually, these student-run chapter chairs, we have 5 SBC chairs. They have conceived this idea, and we are just kind of guiding them on different fronts. And they're so overjoyed when they hear that President-elect and President has given consent to come the event. And then the panel members, Professor Siddiqui, Dr. Debdeep, Dr. Saptarshi. So, I just kind of guided them, but they have done it probably, you can say at the end. So they have done it with sincerity, and it is, as of now, it's going really good.
Yes.
Well, that's great. You guys providing the good leadership, and that's very promising too, because if the young guys are coming up with fantastic ideas like this, and we look more to some of their contribution and ideas on how to really move on to the society. They are the future soldiers. So that's great. Yeah.
Right, sir.
Thank
So
you,
this
sir.
is Elizabeth is one of the APS SBC chairs. She's from IISc.
Good evening, sir. Good
Hello,
evening, sir.
Elizabeth.
We are so happy to have you here.
Good morning, or good afternoon, I should say. Or good evening, your time.
Yeah.
Yeah. I would
Yeah,
like
good
to
evening, sir.
introduce 2 more dedicated volunteers of APS Kerala, Dr. Professor Anu Muhammad and C. Oriji. Are you there? Anu, can you unmute or turn on also video?
Sir, I am there, sir. Yes, sir, I am there, sir.
Right.
Abdullah sir is also there. IEEE APS Kerala section chapter chair.
Professor Abdullah, good morning, good evening, welcome. So let us start the proceedings formally.
Yes, sir. We can start that.
Yeah, I think that will be great.
Yeah, okay. Welcome all once again to All Kerala APS Student Conclave. So now we are going to start the most vibrant session, the panel discussion. So Chinmoy sir has already introduced me. I'm Elizabeth George, IEEE APS Student Chapter Chair of Indian Institute of Space Science and Technology. And I'm very privileged to welcome all the dignitaries to the virtual dais of All Kerala APS Students Conclave 2020. So before beginning the panel discussion, I'm so happy to mention that our student branch was the oldest APS student branch in Kerala section, with the strong motivation of APS leaders like Dr. Chinmoy Saha, Dr. C.K. Anandan, Dr. P. Mohanan, and presently Dr. Abdullah sir. We have grown from 1 to 5 branches in a very short span. I'm very proud to be part of IEEE APS Kerala section, which under the able leadership of Dr. Chinmoy Saha acquired the Best APS Chapter Award in 2018. And also in the same year, IIST received the Best Student Branch Chapter Award. So we know if we are around critical thinkers and successful. So today we are going to interact with the eminent personalities from the APS family. So we have here with us Professor Yahya Andar from Royal Military College of Canada. He is also the IEEE APS President-elect 2020. He received IEEE APS Chen Toche Distinguished Educator Award, which is given annually to outstanding educators worldwide. He also received from the Governor General of Canada the Queen's Diamond Jubilee Medal in recognition for his contribution to Canada, July 2012. So it's honor for us, sir, to have you with us in this. Welcome to Kerala and welcome to APS Student Conference. Thank you for accepting our invitation in your busy schedule and being with us. I know it's early morning for you, sir, but still we are very happy to have you. Thank you very much.
Thank you. I'm glad to be here. Yeah.
Thank you, sir.
Well, yeah, go ahead, please.
Okay. We have IEEE APS Region 10 head, Dr. Javad Siddiqui, who has been a great inspiration to all of us, always been accepting our invitation and never said a no to us. So he is an associate professor in the Institute of Radio Physics and Electronics, University of Calcutta. He is also a visiting scientist at Royal Military College, Canada. Thank you, sir, for joining us.
Thank you, Elizabeth. It's my pleasure. And thank you so much. And my congratulations to you all for doing such an excellent job in behalf of the chapter and on behalf of the society. And thank you. Thank you so much. Wish you all the best.
Thank you, sir.
It's my pleasure to be here. Thank you.
Dr. Chinmoy Saha is an associate professor at Indian Institute of Space Science and Technology.
Thank you. Please go ahead.
He is always accompanied, inspired us. He is a current MTTS Kerala Chapter Chair and APS Faculty Advisor, IIST. Thank you, sir, for joining with us.
Thank you.
Dr. S. Ghosh is working with IIT Indore. He is a recipient of several awards, including IEEE AWPL Outstanding Reviewer Award, URSI Young Scientist Award, and many more. Welcome, sir. We are very happy that you joined with us.
Thank you, Javed, for the nice introduction.
Thank you, sir. And we are happy here Dr. Debdeep Sarkar is with us. He was known to IEEE APS Kerala section from the time he was doing postdoc at Royal Military College, Canada. Presently, he joined as assistant professor in IISc Bangalore. He has also received URSA Young Scientist Award and many more awards. Welcome, sir.
Thank you, Elizabeth, and I'm happy to be here. Let's hope that we have a very fruitful session and interaction today. Thank you.
Thank you. So now I would like to ask Chinmoy sir to proceed with the panel discussion. Thank you.
Thank you, Elizabeth. I was probably not very, keen to take this role because it is a students' forum, and I really wanted the students to take care of the things. But anyway, students have done almost everything. But because of the presence of luminaries, the panel members, President himself, and academicians like Professor Siddiqui, Dr. Ghosh, and Dr. Debdeep Sarkar, I thought I'll take this role and I'll try to take the direction, the discussion directions in a proper manner, in a focused being. As we know, the title of the panel is very interesting and very probably motivating, for the youngsters, because I sincerely believe they will get some ideas, brainstorming and the discussions, the recommendation of the panel members to have a successful journey towards their research career from the UG students' perspective to the PG students' perspective, or in the higher level also. Because here the dominant participants are UG, I believe, and there are few PG and some young faculty members also. As you see, the panel is such a diversified panel with a senior and academicians, leaders, and legends like Professor Yaya Antar, to mid-career person who have also significantly traveled in his academic journey and have achieved a lot of laurels, Professor Siddiqui, and two youngsters who have done exceedingly nice work, and they have got recognitions from the different forum, IEEE forum and the URSI forum, Dr. Ghosh and Dr. Sarkar. And myself being a moderator, probably I belong to something in between, neither too young nor too old probably. So I feel this panel is a very diversified panel, and different people have different perspective towards research, especially Dr. Sarkar and Dr. Ghosh can tell at the grassroots level, because very recently they have completed the journey and they have received laurels and awards. Professor Siddiqui is a very good mentor, motivator, and he have guided so many PhD students, graciously with great success, with great publication success, and their students are also well recognized. And Professor Antar, as I said, doesn't require any introduction. So I feel this panel is a very nice panel, and it is the best panel probably to enlighten on this particular topic. So before I go into the agenda, I'll just share a few slides so that we use the time in a proper manner, in a focused manner. Before that, I just want to ensure that we can hear Professor Antar. Sir, are you there?
Yes, I am.
Yeah, thank you very much, sir.
Can you hear me? Am I audible?
Yes, sir.
We can hear you. We can hear you.
Your video is off, probably.
Yes, I think again there's a glitch.
Fine, but sir is audible today, unlike yesterday.
Sorry.
Right?
Yes.
Yeah. So let me share a couple of slides, and I'll try to take that discussion in a focused direction, because the title is very focused, and then this title has been subdivided into a few categories, so that each of us can talk from different perspective. Just a sec. Can you give me the sharing credential?
Hello?
Organizers?
Yes, sir. Yes, sir.
Yeah. So do you see the slides?
Yeah.
So you see the slides?
Yes, sir. We see the slide.
Yeah. So the panel will enlighten for the youngsters, for the benefit of new generation of students, on the roadmaps and milestones towards a successful research journey from antenna engineer's perspective. As we know, that each research journey is a unique journey, and it differs from area to area. There are so many branches of engineering, but here we'll be focusing on antenna engineer's perspective. The initial panel planned was like this. We had a talk by Dr. Ghosh and then 4 panel members. But anyway, we are really, really pleased, even though because of a technical glitch, to have Professor Yaya Antar as the lead speaker for this particular panel.
Okay.
So before we start, we have, I want to show the people who are behind this program. These are the 5 SBC chairs of different institutes. As you can see, in presence of the president, I want to keep it on record that you see out of the 5 SBC chairs and the corresponding faculty members, it is 50% and 50% the men and women ratio. because the
I
antenna propagation.
can see that. I can really see that, and that's really wonderful. Yeah.
Yes, sir. So
I think you get an award for that from the AP Society, because, as you know, the percentage in the society is 10%, and you have much more than that. That's
right.
great.
In fact, yes, sir.
Okay, go ahead.
Yeah, so this is the activity of these 5 SBC chairs, and we are just kind of maintaining them. And these are from IIST, then GC Barton Hill, then Musaliar College of Engineering, then from Alia, and then newly formed Cochin University of Science and Technology, which was inaugurated by Professor Anthony yesterday. So with this very basic introduction and a direction towards the panel discussion, let us start the our journey on roadmaps and milestones towards a successful research journey and antenna engineer's perspective. As you can see from the slide, the areas are subdivided. We'd request Professor Anta to be the lead speaker, and he'll be enlightening on APS opportunities and new initiatives for young researchers. So I request Professor Antar sir to talk for initially 5 minutes. But before that, I would request him to complete his presentation that he, due to the technical glitch which we couldn't complete yesterday, and then we'll come to the subtopics by other panel members, by Professor Siddiqui. Then I'll be talking on few aspects, and then Dr. Ghosh, and then Dr. Sarkar, and then we have few questions which are already taken during the registration process, and then we'll go to the open session. So over to you, Professor Anderson.
Thank you again, Chinmoy. And am I audible?
Yes, sir. You are audible.
Yes, you are audible perfectly.
Okay, that's really a wonderful opportunity, and I thank you all again for doing such a wonderful initiative, and I think you should continue that more. And actually, it would be a good idea if you write something about that and get it into the AP magazine, so that people around the society would know how the Kerala chapter and how are you moving forward. And for the youngsters here, I think there's quite a bit of it to take home, and you can see how some of your colleagues here, the leaders, that you heard now how they started their journey and the interaction to society. They are all achieving wonderful things, and they are on their way to to make more contributions. And you all should follow these leads. And Chinmoy said it's a long journey. Yes, I guess I have had the longest journey in all of you, but it is a wonderful journey, and you enjoy it as you move along. And so all the best. And on behalf of the AKAPSSC, I really again congratulate you, and look forward to seeing you all in person and so on. Mentioning the AP Society, I'll just start by giving some of you an idea of what the society is made of, and what opportunities you can have, and so on. And I also should mention that the AP Society is now in the process of collaborating with the MTT Society and the EMC and other societies, and the future events could, or even some functions of society could involve collaboration with this, so that gives you a wider opportunity to participate. So I have a bit of a presentation here, which I thank Jawad for helping with, and if I can share it with you. I hope I don't run into technical things here. Can you see it?
Did you share it, sir? Are you sharing it?
I did share it. Can you see it or no?
No, your screen is not yet in the sharing mode.
I thought I did try it.
Okay, because I can still see that yellow triangle there, which indicates a glitch.
You see it now?
No.
So, sir, could you
Can I
please
something?
share screen?
Can I share the presentation, and if you can see, and I can run through the slides?
I think it's getting shared.
It's getting shared?
One, like in the screen, one message popped up that he's, but again,
so give it some time.
Oh, you see it now?
No. The slides, I cannot see it.
Yeah, it's trying to share contents now, so I might have a bit of difficulty with.
So,
I think Dr. Siddiqui
can probably share the link and set top, as you said.
Yeah, maybe Jawad can.
Yes, I'm trying to do that, sir.
Yeah, because it's saying here it's having difficulty connecting with it. So.
Yeah, sir.
Right.
Okay.
Yeah.
So once you are on, let me know, and I'll.
Yes, sir. I'll let you know. Let's see.
In the meantime, I just want to mention that Professor Antar has achieved almost all kind of awards that are there in IEEE and Antenna Propagation Society. But at the same time,
to go.
So can you see it?
Yes.
Okay, just hold on a second. Yes, I can see it now. Yeah.
Okay.
Okay, so this is, if you move on, Jawad.
Yes.
Well, has been a bit of time trying to define the interest of society, but you can see how it is defined in terms of antennas, propagation, and so on, and all of the aspects of society, and it keeps increasing as we move along. So if we move to the next slide, I think you will see the immediate officers. So we have our president Mahta, and her term expires this year, but she has been very, very active and very good. And I think it's we're looking for more female participants. You have a lot there. So if you move on to the next one. Well, that gives you a bit of idea of who are the various regions of IEEE. So region 1 to 6 is the US and Canada there, and you are part of region 10. And that gives you a bit of the membership, and you can see the number there. The society is over 9,000 participants. In India, you have about 12% of that. It's quite a bit, and you should be able to participate more in society. I'm talking a bit about participation in the activities of the society and in the administration of the society. More members from India should be in committees and so on and interact, and we're working, and I plan to do more of this in the next. Okay, then move on to more details about the society. Membership, and I think these numbers you can find on the society and distribution around the world. But if we move, Jawad, to the committees and look at the distribution of chapters and so on, and look at the chapters you have in India. And I think Dr. Siddiqui here can give you more ideas about what's society offering and so on. But definitely you have more chapters and student chapters in India than any other region of the world. Okay, so that's great, and it speaks to the effort that you're putting in to the very many young, bright researchers and scholars that are coming in. If we move on to the next one, this is actually the chapter chair. He's a very active member, Ajay. As you can see, he is, he's started like everyone, he was born in India, and he moved on, and he is a really, really very active member in the society and take care of that. And he'd be willing to obviously help and address the chapters and so on. Next one. Committees and subcommittees, and this is what I'm referring to. These committees are formed all by volunteers, and they provide support to society and so on. And as you can see, each committee has a chair and the members. And I think the members, when I'm checking lately, there aren't too many from India. So I think it should be having over 10% of the population of the society. You should have more into that. Yeah. Okay. If we move on to the committees and what they do, this is another, the committees and so on. And you can see at the end there the Young Professionals Committee and so on. And if you look at one of the Young Professional Committees, and you should have more members on that. And if we look at the work of one of the committees, that's MGA. And its mission, as you can see, inspire, enable, empower, engage members of IEEE, that's you. And there is actually a committee in the society, and there is a committee on the IEEE as a whole. And one of its functions is to enhance the membership, activities, and so on. And actually, this committee has a budget, and that budget could be used to help activities like yours, like if you're holding a workshop or if you're holding a small conference and so on. As you can see from other committees, that is the case. So there is a budget for these things, and if you have a good function like a workshop, an event like this should get support from IEEE, provided you apply early in the society and move on. And if you see, there are other committees like the DL, Distinguished Lecture Committee, and an event like this, if you organize it again in the future, you could have few distinguished lectures. You can have real participation. So beside the local speakers, the local distinguished you can have actually speakers from around the world and participate. And that would be the case, I guess, over the next little while we have the COVID. So you can have actually any number, provided you plan it ahead of time. So if we move on, Jawad, to the rest of the committee, and that's a repeat of what we're expecting, more growth, we hope. And if you move on to the DL and other committees, so these are actually, I don't know if you're all aware of that, but these are the publications we have in the society. So we have the typical ones, or the old ones, the tab, transactions, and AWPL, and the magazine. And as I said earlier, I think your event should be advertised in the magazine. And then we have some new journals that just came up, and well, not came up, some of them have been around for 3 years, and they are in conjunction or collaboration with other societies. So these are, these are the publication of society. The society also offer other activities in terms of education. As you move along, Jawad, quickly, because I don't want to take too much of your time. Yes, conference initiatives, and I am working with the 10 chapters, 10 chapters and other chapters in India to formulate the future activities of the conference you have in India, INCAP, and all other regional conferences. If you hold the regional conference and an event somewhere, the society actually can support that activity in terms of, as I say, support for students, support for the speakers, and the activity itself. So there is a mechanism for that to go through the conference committees. And I guess next year's conference would be very close to or closer to you there in Singapore. And as far as this conference is concerned, we don't know. We assume it's going to be physical attendance, but the possibility is going to be hybrid. If you move on to the Education Committee, as I said, this committee has a budget and it offers quite a number of resources, as you can see there. And please try to take advantage of these things. And anytime, any question you have, please go ahead and fire at me or other members of the society. So I think that I don't want to take too much of your time, but I will stop here. There's a couple of more slides. We can go through them quickly. Joette, to just show them. Yeah, and well, there are too many benefits. When I was starting my career, I really wasn't aware of all of these things, but these are all opportunities for you to benefit and to grow and interact with the society. And I hope you keep the momentum and keep being very, very active in the society as you are today. And for this time, and if you have any questions, please go ahead, and I'd be glad to help. So this is my 5 minutes presentation. Thank you. So back to you.
Yeah.
Thank you.
Thank you very much, sir. As we know that you have accomplished almost all the milestones and you have got different kind of recognitions. In fact, all kind of AAA fronts as well as academic fronts, awards, many recognition from Government of Canada. But we also feel like you are very close to our heart because so many Indian scholars and academicians have been immensely benefited with your association. If I remember correctly, like Professor Ghosh from Kharagpur, Professor Botin Ghosh, then Professor Guha, and then Professor Siddiqui, then probably Professor P.K. Shah, Professor Siddiqui, myself and Dr. Sarkar and Dr. Ganguly, and probably Dr. Biju. So you have been a real support from India.
Benjamin from Kerala. Actually, I have one from Kerala.
Yeah.
So, well, I thank you for that. I think your contribution to what we achieved and to society has been great, and I look forward more to to that. And the doors are open here for you guys made the difference, and thank you for saying I accomplished so much. But I think when you live as long as I did, you have no choice but to do more work. Yeah. So thank you very much. It's very, very nice of you.
Yeah. Yes, sir. Thank you very much. So we'll take the questions, a few open questions, and also a few questions that we got from the participants during the registration phase. So with this, we go to in the more technical part of this panel discussion. So for each of the speakers, we have 5 minutes. We start with Professor Siddiqui, who will be enlightening on this particular roadmaps and milestones towards successful research. But he will be specifically focusing towards connecting academic research with industry perspective. So over to you, Professor Siddiqui. You have 5 minutes, please.
Yes, thank you so much, Dr. Saha. It's a pleasure to be here again, associating with your team in Kerala. They have been extremely active, and it's good to see that so many members. I always say that we always have a problem with retention of student members in IEEE, but getting them actively involved. Because as you know, the first chapter, AP Society APMTT Joint Chapter, was opened in Kolkata in 2004. It was inaugurated. The chairman was Dr. Professor Ghosh. He was a founder chair. However, I was also associated, this formation of the chapter, and then he left for Canada, and the owners came to me to have events and organize the chapter. Then Dr. Bhaskar Gupta became the chairman of that. Professor Saha, P.K. Saha became the chairman, and then followed by Professor Bhaskar Gupta. So I was associated with them since the inception of this chapter in India. That was the first AP chapter in India. So during that time, we never had any clue of how to organize events and what are the modalities, because the IEEE Kolkata section was functioning since 1970s. But however, the chapter was formed in 2004. So you can see the lag, the deficiency.
Yes, Professor Siddiqui. We were also part of the journey later on. So
yes,
may I request you to focus towards the theme of the panel? Yes.
5, 6, and then we conceptualized. You remember, you were part of it when we conceptualized the AEMC, the Applied Electromagnetics Conference. So this journey has been, the momentum has, it has always gained momentum from the time it started in the conceptualization, the inception. It started, if you hear Dr. Guha, he visited San Diego, and that is where he learned about an IEEE chapter. And then we formed that chapter in Kolkata. And then you came on board, and you have been associated with conceptualizing IAW, Indian Antenna Week, which you have been a part of it. So, it has been a long journey. Academics at one part and IEEE. So I really separate these two things, though they're interconnected in the sense that academic, yes, my university, I'm on the payroll of the university, but IEEE is a voluntary organization. It's not on a payroll, like whatever time and effort that we're giving to IEEE, it's basically out of love and affection for the subject and for the society, or for connection. IEEE, what I feel, has got us connected. Like today we are having a meeting. It's a part of an academic discussion, but still we are connecting because of this scientific platform and the connection, what we had by forming these chapters and becoming IEEE members. So this should go on, this momentum should go on. And I say that we should induct new members in this in our chapters. And inducting new members, I mean the way you're grooming the students. They will be the future office bearers and leaders. So I'm glad that in Kerala, the students have they are doing this conclave, and I hope the other chapters will learn from this, like how the student can manage and take advantage of this IEEE membership and do these kind of events, because eventually they are from being student members, they will become IEEE members. And eventually they can become IEEE leaders. Like we all have to groom ourselves. It's a long journey. And your mentorship has been excellent. And that what we learned from here, we learned in our journey in the early 2000, mid 2000, you have used that, in Kerala. Kerala was already vibrant because Dr. Mohanan, Dr. C.K. and Professor Anandan, and now Dr. Abdullah is the chair. So I'm sure you all have a very good team to provide knowledge and guidance to the young student members. Regarding the topic of my discussion, which you said attaching to research interest, research should be tangible. When I started my journey in doing research in microstrip antennas, there was visit by Professor Raj Mitra in 2001. So I was showing I just initially was inducted in the PhD program as in the Center for Advanced Studies in Radio Physics and Electronics. And I was showing my slides, I was working on broadband microstrip antennas in 2001. Professor Guha published a paper in IEEE transaction just a year before that. So when I was showing my slide, the one question Professor Rajpitra, he asked me, is it tangible? I never knew I never even knew the word tangible. I said, no. I mean, this is what I'm trying to do, and this is what I'm trying to publish. He said, no. Is it tangible? Are you selling to the industry? Are you giving to the industry? Are you working for someone? So that was the time when I had no clue. I thought we were doing like lateral research, the research for the sake of research. Research for the sake of just doing something new, taking an existing work and expanding on it, and doing something new. But we never knew that it could be related to industry. We could have industrial project. So that was the very first thing that struck in my mind, that why are we doing this thing just for the sake of lateral research, just to do something for publication? But nowadays, like the opportunities are there, and there are industries, unconventional industries that we don't even know. When our leaders talk about generating manpower for microwave and RF engineers, generating manpower, but where are we going to place them? Do we have enough industry? We have the national organizations, we have the ISRO, we have DRDO and the national laboratories. But other than that, does the students know to collaborate, like which other organizations to look into? Because there are lots of antenna and antenna, if I stick to antenna, there are lots of antenna companies in the US, like the Boeing, Bombardier in North America, the Boeing, the Bombardier, Northrop Grumman, and space organizations, private organizations like BAE, Thales, Honeywell, all the radar providers for the aircraft, they're done by Honeywell. Now there are automotive radars coming in, automotive industries like the BMW, the Mercedes-Benz, they are coming over to short-range, long-range radar at high frequencies, at millimeter wave frequencies. So they are looking for antenna engineers. But what I felt when I was grooming the students, the opportunities were limited, not in the sense that the opportunities were not there, but the knowledge was limited. Even with us, we couldn't guide them because we used to push them to ISRO, DRDO, or BSNL. But there are other avenues to look forward to. So that is where I would like the students to look for other areas, because now automotive radar, RFID, these are the things of the future. There are industrial applications, wireless applications for industries, healthcare, RFID tags for healthcare management. So there are lots of opportunities where the students can look forward to, other than joining this only this CA industries, because most of antenna engineers, why would a student learn microwave engineering, especially bachelor situations, if he goes to land up with a job with TCS or Infosys? So I believe, this training has to be done, this message has to be propagated, that there are other avenues to look forward to. We also need entrepreneurs in the region, where students can look up to. So we need a team of trained entrepreneurs, so that we can have antenna industry and RF and microwave industry in the nation itself. So that will, I think we have to have a roadmap, and IEEE can definitely collaborate. We have an industry initiative, so the industry initiative committee, probably they can look into it and have a collaborative events to make the students aware of the opportunities that are available in India and worldwide especially for budding RF and microwave engineers and antenna engineers. Thank you so much, Chinmoy.
Thank you very much, sir, for excellent illumination from different perspectives, because you have so much of experience and on different technical fronts as well as the leadership fronts. So I really did not want you to get time limited. So
yes, time limited. I would also would like to tell you that this guidance was also provided when I came to RMC Canada. I came here in 2007 first, and then starting from 2008, I've been coming here, researching every year, taking advantage of the facility, and that has really grown. Here, North American research, what Professor Antar has guided us, you were also involved here in wireless technology research, transport research. So it was always tangible with the industry, isn't it? It's a collaboration between the the industry and we're doing something on the one of the industry or which is application oriented. So that avenue has, like working here has definitely given me a guidance, a roadmap of how research should be, how it should be linked with the industry. And I thank Dr. Professor for that, for giving us the opportunity of exploring these things which we were unaware of.
Yes, definitely. So your involvement with multiple fronts, with of course starting with activities with Professor Guha, both on research as well as the IEEE leadership, the conferences that evolved in Calcutta, and then it has propagated. I believe some part of your discussion you covered that area, so that from that also some research ideas and some research impetus the youngsters can hear. So the point I believe Professor Siddiqui wanted to say or rather propagate was by attending conferences and being involved in IEEE activities, you get a networking, and that networking actually in long run help you. That was one of the aspects. And the second aspect, if I can try to summarize from Professor Siddiqui's perspective, is that while finding a research problem, connecting the problem with the academia, I mean in the industry, is very, very important. At the same time, I understand the industry also should invest in the academia, and they also need to see what are the courses and being offered, so that a holistic environment and the proper connectivity from the both sides will probably help the universities also to mold and to tailor the curriculum so that it becomes pretty close and proper impedance matching is there. So these are the main point Professor Siddiqui was mentioning. In addition, he was talking about few points which can be conceived by youngsters like RFID, wireless power transfer, and some of the other technologies which are very close to industry. So those are the things probably is that he talked on. So you can,
I can see a question here. I can see a question here from Shivada.
So we'll take the question later on, sir. Please.
Okay.
Yeah, we'll have the open session and the other part later on. Yeah. Thank you. Yeah.
Thank you.
So with these excellent deliberations from Professor Siddiqui, we move to the next part of the speaker, which actually is myself. I am talking a lot, so I don't want to really talk more. So, but the point that I want to cover is, for successful research journey, the fundamentals and the teaching part also is very important. So when I am saying teaching and learning, so one is from the educator's perspective, that is from the faculty members' perspective, another is from the students' perspective. So the whatever antenna research or the RF and microwave research, Professor Antar was also mentioned, an entity are always very close, and now they are trying to be more close on certain initiatives. So whatever type of research at the end of the day you are going to do, your fundamentals comes from the basic courses of electromagnetic theories, propagation, antennas, and so on and so forth. So in my experience, what I have seen, like the way we teach this type of courses, I'm talking from faculty perspective, sometimes is not the best. Like we at the very beginning, derivation, calculations, probably students get their energy start getting decayed probably by few dB after every class, because we always talk about the Maxwell's equation. We derive so much mathematics, directly go to the board and do those kind of stuff. But definitely some of the students can cope up with that. But at the same time, if we can teach these courses in an effective manner by mingling the softwares and some of the CAD tools and give it more physical significance rather than just doing the mathematics, definitely mathematics would be needed at the end. But at the same time, giving more practical exposure, sometimes taking them in the lab, even within the theory class, probably will help people. So these are the certain perspective that young faculty members can take. And from the students' perspective, because this event is from students, you should also know, though even though the mathematics is involved, but it is not the mathematics, it is the physical significance and it is the end application. But to understand the subject, the mathematics is the backbone that is needed. But at the same time, you can take initiative and you can try to, get familiar with some of the CAT tools, and nowadays software and different students version are available. You can use TSP, AKAPSSC, and some other kind of software. Some of you are very good in MATLAB coding and all. So with this also you can solve many things. You can model a rectangular wave and try to visualize the T10 mode. It is not the end of the after 10 classes of calculation and Helmholtz equation and then solving the equations like method of separation of variables or involving Bessel's function for circular waveguide or circular cavity resonator. That is one approach. But the second approach is you should also try to think innovatively, try to use those CAT tools available in the colleges or the student version or the free version. Something you can approach the nearby, the resource center, the institutes which are having those tools. You can visit them and you can try to design some of the things. And then what happens is the theoretical understanding and the ability what Professor Siddiqui was mentioning becomes more closer. So you get a real idea of how move type, what is the complex move, maybe in dielectric resonators or in so all those things you can look into. Similarly, using the ADS, you can see a lot of perspective from the circuit simulator. So this is the point I wanted to mention, that for successful research, the solid background and the solid foundation is very, very important. So for that, we need to sometimes have a shift of in the process of thinking, in the process of learning, in the process of educating, and finally getting the concept pretty much absorbed within ourselves. Because ultimate aim of teaching is the assimilation of the knowledge. So if that happens, then your background is very strong, foundation is strong. So you have the foundation done on which you can
sir, your sound is breaking.
Fine. So
Sorry.
with this, I conclude my part. Am I audible?
Yeah, your sound was breaking towards the last part. It was breaking for some time. Hello, sir.
Hello?
Yeah, I think there is some issue with his connection.
Yes.
Yes.
We
I
missed
think
Chinmoy. I think this yellow triangle.
Yeah.
Okay.
Hello, sir. Chinmoy, sir.
I guess let's wait for a minute. I think he will be back soon, like probably.
Yes, I think there's like Chinmoy, we lost Chinmoy. It's coming back and forth.
Yeah.
So probably he's logging in again.
Yes.
So yes, there even something I missed, like the wearable industry, the like wireless wearable technology that's coming up in such a big way. That's another like avenue which
Yeah, I think lots of avenues, like in terms of wearable industry, also in terms of the we can classify in the various forms, like in terms of the cellular, in terms of defense, in terms of the space applications. So we are really looking into several new systems which have the integrated antenna and communication engineering aspects.
Yeah, so, exactly.
Yeah, so and it is I think one of the points that yesterday I think Professor C.K. Anandan, he was also mentioning that we need to think from the student perspective. Like we cannot only focus on the antenna as a single component all the time. We have to think about how it is being integrated with the system.
It's a system integrated antenna which has to be taken, because the standalone antenna, when we do a measurement in the lab in ideal condition, it may not work in the same, may not function the same way when it's embedded in a system. The parameters might change. So the system integrated antenna, the testing, that should be taken care of.
Yes.
And,
yeah, I think, and maybe after Dr. Saha, let's wait whether he is joining in. I think Saptarshi, Dr. Ghosh, he can talk a little bit about the ways to how to develop the successful journey, and I think you already have got the topic name mentioned with you. So maybe you can just share your thoughts and share your experience on that.
And you know, like the IEEE is, you know, like if students have more access to journals, and if the journal, you know, publication fee of the journal is also an issue. Like, you know, networking is so important. AP,
Yeah, I think the IEEE networking and that part, like it is just as you were mentioning, like the access to the journals and access to the open literature. That is a very important thing, and I think it is very important for any of the colleges, like whether it's in Kerala or whether we are talking from a global perspective, like for the students to have access to the current IEEE literature, because
yes, the state
from
of
the
that
open
is what the
literature,
state of the art. You know,
yes,
like
yes.
a couple of decades back or 1.5 decade back, I can say that the journal used to take, once you send it for publication, once you write a paper, it will take 2 years to get published.
Yeah.
Almost
I think
1.5 to 2 years to get published. But nowadays, you know, state of the art, things are changing so fast. There's a quick turnaround time, and you know, things are.
And we also have the early access, like
yes, you have
the
the early
papers which
access.
are not formally published that are coming to. So anyway, I think we can move to the so the Saptarshi's part. Like he can maybe share a little bit about, like, take 5 minutes for his thing. Then maybe I think Dr. Shah has joined the meeting. Let's see if we can hear him.
Okay, so let's wait for him, or shall we?
Can any one of you call him and
Yeah,
just?
Yes, sir. I've called him. Sir will be joining very soon.
Okay. So let's wait for him then, Saptarshi.
Yes.
Let's wait for him for, I think, 1 minute. Then we can move.
Because you know, I'll give you another you know, like my anecdote. Like when I used to see the transaction magazines, if you see the last page, there were so many antenna companies who used to sponsor antenna magazine, not the magazine, the transaction. There were so many antenna companies on the backside of the cover. You know, they were the biggest sponsors. And I always used to wonder, why don't we have company antenna or RF industries in India, you know, who could.
Yeah, you're absolutely right, sir. I think it is the point that you also mentioned regarding the entrepreneurship and like creating the startups and developing systems indigenously. Like I think in many ways we are like for the antenna part and also in the broader part, we are sometimes dependent on other industries. So in terms of like the indigenous development, it is also important. And I think with the tools that we have right now, like the way we can design antennas and we can like probably test it, and like in terms of the software level and also in terms of the hardware, there are testing kits and training kits available, and we can collaborate with the industries so to understand what their perspective is, and the students or the young researchers can channel their work in a way that it can be fit into the broader perspective.
Exactly. Instead of doing a lateral research, they can do something tangible.
Yeah. Your point was absolutely like on target.
That is what is required in the industry. Even it might be a small RFID patch, but what is, you know, like what's the demand? It may be what will be useful. It will be used for some application. That's the need of the hour, I believe.
Yeah.
I think, can somebody ask Chinmoy whether we can go ahead with Dr. Saptarshi Ghosh's talk? I think he's queued next, I believe.
Yeah. I think he's queued next. So let me just.
Chinmoy has joined recently, and again he has.
Yes, probably, you know, like he was not audible.
Yeah, he's probably having some of the issues.
Can you hear us, sir? Are you there?
Yes, I am there. I'm listening. I'm listening to all of the interesting.
No, sir, you are the beacon. You guided us. We learned from you. That's what we are discussing here.
Well, I'm learning from you more, actually. So, yeah.
Okay. So thank you so much for being there.
Just let me talk to him once, I think.
Assalamu alaikum.
আচ্ছা, তাহলে আমি সপ্তর্ষিদাকে তাহলে শুরু। আপনি চেষ্টা করতে নিলে মোবাইল থেকে। Yeah, so I hope you can hear me. So I think Dr. Saha will be joining soon, so we can move ahead with our Saptarshida's part, and then I can also speak. Yeah.
Okay.
Saptarshida, yeah, you can share your views and thoughts. Yes.
Debdeep, what's the topic for Dr. Ghosh?
Javed sir, my topic is methods and milestones towards a successful journey.
Oh, fantastic. Please go ahead.
Yeah, please go ahead.
Where there are so many big personalities are there, particularly Professor Andar is there. I'm sure that I am not the right person to talk about the successful journey, but what I can share is that my journey towards my PhD, postdoc and master's time, and whatever the hurdles I have gone through, whatever the processes I have gone through, maybe if I'm share with you, help you to understand or relate yourself with myself, with my journey, and from there you can find some solutions by yourself. Okay, so there is that already Professor Chinmoy sir has already talked about the teaching activity. So here I'm trying to talk about what are the research activities you can do during your master's or PhD or postdoc and so on. So regarding first option, and what is the first and foremost point is that read the research article regularly. So you have to stay connected or you have to stay updated with your domain of articles. It might not be possible to read all the antenna topics, but if you are working on a particular articles on a regular basis, go through you create the you can read. For this you need that IEEE Explorer. So if you become an IEEE member, it will be very good for you, IEEE student member. So then you can read the articles from your own account. You do not need to depend on any other institute account. You can go anywhere, you can study these articles either for IEEE transactions, magazine, letters, or MWCN micro component letters. You can study the conference papers also. Now conference paper also come inside the IEEE membership cases, and now you can not those papers you can go through them. Sometimes the good option is that you can create some Gmail alert like the Google Scholar alert. You can create some Scopus alert where you can get the updated articles on your topic. Particularly if you are working on some good like some monopole antennas, dipole antennas, Colphic antennas, you create that alert in your Gmail or Google Scholar or Scopus, and you will get the frequently either weekly or bi-weekly some Google Scholar. So that to stay connected with the recently updated or the updated articles is the far like the most important aspect of the research scholar. Second one is that try to resimulate a few papers in your earlier days of research career. When you are starting the research career, try to check that okay, whatever you are thinking regarding some research paper, whether this is like appropriately like it is matching with the paper or not. Sometimes you are working on an antenna geometry, and maybe whatever the concept you are thinking for the paper, it is not matching. So if you have the simulation software, you do those things, you simulate those things. If you find some matching, okay, that means your understanding or your process of simulation is correct, then go ahead. You do not need to resimulate each and every paper, rather you just simulate a few papers, and then afterwards you only study those papers. And whenever you study those papers, just don't blindly study. Try to study those papers and try to understand whatever the concept underlying inside the paper. Why the paper is giving some multi-band antenna geometry? Why this number of peaks are coming? What will happen if you increase the length of a geometry? The frequency is changing and increase direction is changing. You do not need after a few months or few weeks. You do not need to go through the resimulation at all. If you study the paper, you will understand in which way the structure is working, in which way this concept is working, in which way your algorithm is working, and how you are going to improve this algorithm in subsequent days. So when you are understanding those things by reading this paper regular way, you will maybe understand the basic concept of this. Now, there as the either you are going for the simulation work like computational techniques, or you are going for the experimental work. So when you are going for experimental work, it is like advisable to work or at least fabricate one small prototype by yourself. Either you can, if you are working on antenna, design a simple prototype with some connector. You measure the structure, reflection coefficient, patterns, etc. Or you are working on some frequency electric surface or metamaterial, or you are working on filters or SIW technique. Just fabricate a small geometry, and you see that whether your fabrication techniques with the measurement response or not. If it is largely defective, that means somewhere you're either in the fabrication there will be reduced tolerance, or your measurement is. So it will be better, easier for you to go for a small type of fabrication, and then you move to your own proposal. Sometimes what is happening, someone is designing a costly frequency electric surface periodic structure. Someone is designing RT based antenna geometry, low loss antenna geometry. And now if your geometry is not working after fabrication, the cost is gone. So then you sometimes this fund is not available in the next time. It's better to fabricate this antenna in a lower percent or in a low cost way, and you check that whether it is working or not. So once it is working, you got this, okay, your concept is fine, and then you go and you fabricate your own geometry. This is one. Third point, you can consider to try to work on the low cost way particularly. Suppose if you need to fabricate something, you do not go for that. Like sometimes always in India, in our country, most of the time fund is limited. Many of you are working on the private engineering college. Many of you are working in the government engineering college with limited funding. Particular research funding is. So those cases you have to think of that how your cost can be limited. Particularly if you're working with the antenna, try to use some low cost substrate like FR4 or something, or if you go for the attitude or something, so then try to minimize the substrate geometry. That means ultimately at the end you have to reduce the cost. If you go for the FSS frequency electric surface and you cannot use a huge amount of structure, so then instead of going for the free space measurement, you go for the periodic parallel plate waveguide measurement or rectangular waveguide measurement. So ultimately the cost reduction is up to you, and then you can go for that. So then next part is coming for your response. Note that the research has to be done by yourself. That means the student or the faculty who is doing the research by yourself has to be done by himself or herself. So by searching which type of connector is needed, which type of lamps or diodes are needed, which type of substrates are needed, those things have to be taken care by yourself. Those things by yourself, and then you approach the company by yourself, contact the company, and then you are asking the company quotation, and then you try to find the source and then apply those things. You should not wait for your faculty is coming and you asking for which substrate you are going to use or which lamp component is going to use. You go through the paper. Obviously, when you are talking about some resistive field or conductive field, obviously you are getting that idea from some other paper. So go through that paper. This paper, the information is already given. So then you take this, you have the internet, Google it, search the product, and then you search the. In IIT Kanpur, when me or Dr. Debdeep was like his student, we have to search a lot. We themselves we have asked the companies either in Germany or US. We themselves asked the companies that okay, how we are going to purchase the things from Mauser. At that time, we have to find. We didn't know how to search the company. We have gone to them. So in this way, you can do everything. Ultimately, at the end, you have to find that this research is yours. The work, whatever you have carried, it is your work, and the publication is coming, you are going to be first author or one of the co-author. So it is your work. So you should not expect that your faculty or your supervisor is coming and telling you which component you are going to use. If the faculty is going to tell, it is very much good opportunity or helpful for you. But if the faculty is busy in other teaching activity, research or administrative activity, you should not wait for the faculty to come. You do it yourself for your own journey. Particularly if you see at this type of, I don't think that this is your own problem or this type of hurdles are there. If you see that there are many dignitaries who are present here who have done or who did their PhD with different types of hurdles. Just think of that. Now we have the electromagnetic softwares like AKAPSSC, IIST. You think about when the Professor Akhtar or Professor Rajmitra, they have done their PhD. At that time, there was not at all in or that type of things, and they have calculated and they have done so much hard work at that time. So now we have already commercial available softwares are available to almost everyone. So So you have to do the work and you have to do the searching part by yourself. So at the end, it's up to your research, and you have to do how to, if your funding is limited, you have to do by yourself, how to reduce the funding from your experimental domain. If your work is on the computer science domain, so then there will be no much funding is required. So then you have to check that how much, in which way you can improve yourself. So, and the last one is that there will be various glitches will be there, obviously, from when you are starting work, results might not match. Maybe you have to see resimulate the geometry again and again, but don't lose hope. Most of the PhD student or most of the like you have found here, like Dr. Debdeep or Professor Antar or Professor Javed sir or Dr. Chinmoy sir, everyone have found, everyone has received some of the hurdles in their own ways, and they have devised those resolutions by their own ways, and the resolutions are different from one person to another. You have to find a particular solution by yourself. That solution will not be equal to one person. You have to find in future you are going to resolve this problem, and you are going to go forward, and you have to make a journey that will be, maybe it will be full of hurdles, but at the end it will be yourself happy, satisfied, and maybe it will be successful. So at the end, the three words: explore, execute, and excel. Thanks for my set.
Thank you, Dr. Ghosh, for the nice deliberation. I think you covered a lot of points which are very. It was very important that those points are put forward in this forum. I think the importance of literature survey that you mentioned, that is a key thing. And I still remember we could, if you remember, many of our colleagues also, we used to explore the articles that are published in the IEEE almost every day, like a newspaper kind of thing. The way we check the news, we used to check the early access kind of articles over there. So that is indeed, that is a very important point. And the second point, I think we are all thankful to our mentor, I think Dr. Vaibhav Srivastava, who always focused on the part of the development of this cost-effective things, like use of low-cost substrate, use of realizable things that are probably within the particular budget. So that is another important. And finally, I think the point of not losing hope and finding our own ways to beat the whatever hurdles we are facing. That is also so. These are, in my opinion, the students or the people who are listening here, they have got a very good advice, good piece of advice, number of things from Dr. Ghosh. And yeah, I think we do not all have Dr. Chinmoy Saha yet on board. I think he is facing some of the trouble regarding the audio. So I think after Dr. Ghosh, I was scheduled to talk.
Yes, I think Dr. Sarkar, you are scheduled to talk. And thank you, Dr. Ghosh, for your excellent insight. I'll share some experience with you probably in the later session. But yes, thank you, Dr. Sarkar. Now we would like to hear from you, your views. And
so actually, thankfully, Dr. Shah already informed us about the things that we are supposed to say. So I think this point that I will be talking for, I think 4 to 5 minutes, is mostly regarding the use of these EM simulation tools and the way we need to probably think ahead and try to think beyond some of the existing whatever commercial softwares are there. But from the student perspective, why it is important to pursue the domain of computational electromagnetics. That was my generally the brief that I was given. So I think Dr. Ghosh already covered a few points regarding the use of the softwares and why studying the basics of the software and understanding the functionality, not just plugging in some parameters or drawing some geometry there and getting some results. It is also very important to interpret the results that are coming out of the structural simulation. And I think I will also take the point that Professor Siddiqui also mentioned, any work that we are doing, we have to have some broader goal and how it is being helpful for the industry and how it is helpful for the society at large. So that view should be there. Let me start with where we have the importance of these computational electromagnetic tools that we are doing. in the phase of research, we start with the literature survey. We try to find out, identify the problems that are there. And then at the end, we are going to build up some antenna system that might be useful for some industry, that might be useful for some application in space and application in some defense, like maybe on some aeroplane, or let's say in a space in some satellite, there are some CubeSat kind of thing. And also we have our own cell phones and all those kind of stuff. So the eventual culmination is there, starting is the literature survey. So in between, like building up, it's not possible for us to always build and then throw away the fabricated stuff. So there we have this purview of using the EM softwares. And it is very important to understand that these EM softwares have taken quite time to evolve. Like earlier, I think 30 to 40 years back, the computer system and the tools or the softwares, how to program a particular large geometry, all those things were not that much available at that point. So people had to rely on writing their own codes, and like it used to take a lot of time to do that. But thankfully for us, we are now, like our generation, we are now having all those tools. Like we are having HFSS, we are having computer simulation, CST, we are having FICO is there. Several other electromagnetic tools are there. So various stages of the researchers, like be it a master student, be it a PhD, it is important to learn the basics of these tools. Now, master students generally have a very limited time frame, and they are looking for other career opportunities that might be going for a PhD, that might be joining for an industry. So since the time frame is slightly less, if I say from an Indian MTech perspective, so it's not always possible to go into the intricacies of this software, right? Like how it functions and how it does. So, but again, importance of the physical insight cannot be like overruled. We have to understand that how which element or which parameter we are changing and how it is responding into some S parameter change or some pattern change, why it is happening. That questioning should be there. But my point is, understanding the computational electromagnetic software might not be the favorable option for a smaller time frame. Now, if we go into PhD, I think that for any guy who is doing a PhD in this antenna propagation domain, like be it antenna design, be it FSS, it is very important to know about the algorithms and how the various softwares, like let's say for example HFSS, it is using the FEM or some other tool, it might be using method of moments, and there is CST, it might be using the finite integration technique. So what are the basics of these tools and how they are being, how we should take the basis functions and how those things are there? Because in that way, some of the, what is the purpose of the simulator? It is like to emulate whatever will be happening in the real life. So to understand that, it is very important to understand the software or the code that is being there, and how we can tweak some of the parameters to get results that are better matching with the real life scenario. So that point, I would strongly suggest that there are several online resources available. Like in NPTEL, there are courses on computational electromagnetics, and from Indian perspective, I am saying, and in the YouTube also, you can get a lot of like illuminating lectures and stuff on the computational electromagnetic tools. So it is very important for UG students or the students who are just starting their journey to understand the basics. I'll share a little bit of my experience on that. While I was a UG student, my BTech project was on this finite difference time domain technique. Like if you take the 4 basic Maxwell equation and you choose the Kyle equations, so just simply discretizing those Kyle equations and applying the proper boundary condition, you can develop a very rudimentary kind of FDTD algorithm that can be used in a 1D, 2D or 3D. So there was some books by Pavlov and then Sullivan, and which I followed, and at that point I did not understand any of the electromagnetics, but I just coded it because it was in C language, and I tried to port it in MATLAB and use that. Later on, it helped me immensely to gain insight to what actually is happening. Like I could see the wave propagation myself from the simulation. I could see how it is illuminating certain structure, how the scattering is happening, how we are getting the proper current distribution from it, or we are getting a proper, what should I say, like radiation pattern from it. So the coding with the FDTD, it did not happen in a single day. It took me almost 5 to 6 years, because that was in the, I think Saptarshi also knows this part. Like I was designing some antennas and doing some development kind of works. But parallelly, I used to work on that FDTD tool just for the sake of my own understanding. So that actually helped me to gain a lot of insight, and later on, it was also very favorable for me for some of my research also. Like I was very much, what should I say, thankful. I should be very much thankful to Professor Antar for exposing one particular area of research that I would like to share with you, that on the electromagnetic energy. So electromagnetic energy distribution, the antennas, this is an old problem, and almost 70 to 75 years back, like there are a lot of research on that. So Professor Antar actually motivated me to work on that domain using this FDTD tool. So it all comes together and there is some kind of connectivity. So using that tool, we explored some new research, and some of the papers in probably it will come out very soon in the AP magazine. You can check. So my point is, it is very important to focus on the computational electromagnetic tool and coding on your own, so that it might help you for in the long run. And now I would end with a small point on the available toolboxes. Like there is, I had lots of discussion with one of my collaborator, Dr. Siddiqui, on this. It's regarding the antenna toolbox in MATLAB. So people who have access to MATLAB through some license or through like the online MATLAB version that is available to registered institutes, you can explore the MATLAB toolbox, because it gives you some kind of method of moment pre-coded software, and it's very useful for teaching and for learning new concepts, and also to understand the computational electromagnetic part. So with that, I will finish my deliberation. And I think is Dr. Saha here? I could see him probably for some few moments.
Am I audible now?
Yes, yes, you are perfectly audible.
Very strange. Probably you have seen my name is changed now. I have connected through my wife's laptop now.
Yeah.
I don't know what happened. All of a sudden, I was disconnected in audio.
Yeah, well, I can understand the problem, because this has happened to me in the past. Like there are sometimes this issue in software, like this WebEx or this kind of platform comes up and we cannot help. So it's good that we are having you back here. So just to update you, I think Dr. Ghosh talked about his part on the how to develop the successful journey, and I have shared some of my thoughts on the use of EM software and importance of the computational electromagnetic research. So we might take the questions or go ahead with that.
Yeah, so there are a few questions which are received earlier. So sorry for the interruption first. I believe, even though I could not hear, I believe the sessions were continued properly. Dr. Ghosh and Sarkar are best in managing the situation in any given condition. So I hope it is being continued in a proper fashion. So we have Professor Antar, Dr. Siddiqui, everyone here, right?
Yes, we are there.
Yeah. So can I first throw a very thoughtful question from a young researcher who is trying to do some work on dielectric antennas, but the query is like it is 2-3 questions I am combining together. So the input is I don't have that much of solid background because I am just a BTech engineer, but I want to do very high-end research on dielectric resonator antennas with a different kind of applications. So may I request you, sir, to illuminate, like as a bachelor's or just as an undergraduate student, how he or she can proceed towards having a successful career on DR antennas and its diversified applications.
Who is it directed to, Chinmoy?
Yeah, I am directing this question to Professor Antar.
So are you there?
Yes, can you hear me?
Yes, we can, sir.
So, sir, could you hear the query the young researcher is having targeted towards dielectric resonator antenna, but his background is just BTech?
Well, I think the term dielectric resonant antennas looks big when you don't know too much about it. So dielectric resonant antennas, it is a dielectric and it is a resonator. So I think what you need to do is look at some of the survey articles or introductory articles on DR. And then once you know what is DR all about, and it's just a dielectric resonator with resonator modes and so on, which is basically what you have in PTEC and when you're looking at waveguides and waveguide modes and so on. And that would remove the mystery you have. There isn't really too much in terms of sophisticated tools that or sophisticated analysis that you need to be particular to the electric resonator antennas. So once you understand the physics, as was said by previous speakers, get to understand the physics of what is happening in the DR, you can actually use your imagination to do whatever you want with it. Okay, so it's not as mysterious as it's like anything else. The basics are the basics, and they all go back to looking at a resonator, assuming certain boundary conditions. There are various ways of looking at it. So you need to understand the physics, and then when you have a simulator, you can get in the simulator and use the simulator to verify some of the physics. And from there on, you're going to develop a bit of understanding on what is really happening, how does it work as an antenna, and how you connect it. So, if you had the very undergraduate basics, undergraduate courses in EM and waveguides and waveguide modes and so on, here you go. So it's not, people try to make more of it than it is. But you have a resonator, you have various modes, understand the modes, understand these things, and thereon you can design antenna using DRs and look at what people have done in that. So you really don't need a highly mathematical approach, too much analysis and so on. What you need is basic understanding of the principles, basic understanding of the physics involved, basic understanding how a mode radiates or doesn't radiate, and how do you feed it, and how to make an antenna out of it for the particular application you're looking for.
Right, sir.
Right, sir.
Thank you very much. So
maybe Jawad want to add anything to what I said?
Please.
Yes, perfect, sir. You're right. Just understanding, visualizing, conceptualizing, that's very important. Sometimes I say that our first antenna engineer, if you look back, like when we used to have the prehistoric time, the TV transmission using the Yagi antennas, during a storm, the antenna used to rotate, it used to change direction, and there was no clear TV reception, right? So what we used to do, the antenna is usually the terrace. So we used to send either a servant or somebody who's, agile, to just go up the terrace and rotate the antenna until the reception is on again. So what I say that he was the polarizer. He used to change, align the antenna to polarization without even knowing the basics of antennas. So, that's an interesting thing, because when we learn about polarization, and that's when I used to send people on the terrace, or the technician or anybody, who could turn the antenna to polarize it in the proper alignment so that the reception is restored. So this kind of conceptualization, we never had idea because we never studied about antennas during that time when we were young. But this is what a technician would do. Even a person who erects a tower, the TV, the mobile towers and all, he has to polarize the the angle that with the antennas and with the sectorial antennas that they use. Probably they learn from their experience. Probably they may not have the theoretical background or the theoretical knowledge, but the technical knowledge that they acquired when they work with the system, that is important. So, anybody who has an interest he may not have a proper technical knowledge, but he has the interest. If he can visualize things, if he knows what's happening, probably he'll learn in the trade itself.
Yeah, maybe I should add actually something here. This is my actual experience with DOR, and I remember that it happened in '89 when we still didn't know so much about the electrodes and the antennas and the modes. So it was Ahmed Keshk and myself, and we actually had a resonator and connected it to a network analyzer, to figure the return loss. And if you have something connected to the resonator, you see resonances. So we actually had multiple resonance over the spectrum. So simple thing we did, put your hand on the resonator.
Yes.
And you actually see some of the resonance disappearing or varying, and you see some of them are not being affected. Guess what? That gave us an idea which modes are radiating and which modes are not radiating. Just by the simple experience, you put your hand on the resonator. Well, it's not radiating, so the return loss gets affected. So it's radiating, and you can see it. So, just simple experiment like that, looking at the resonance, looking at the frequency where this is happening and so on, and going back to the data, and this is there, you can actually understand which mode is radiating and which mode is not radiating. And you see it right in front of you from a simple experiment like that.
Yeah, sir, please suggest some book for understanding the modes of a resonator, sir, a book or an article, if you don't mind, sir.
Yes, there is actually a couple of books. There is a book by Aldo Batosa, and there is a chapter in the Antenna Handbook that's written by John Bolakas. You can Google all of these things. And there is the earlier book by the group in Hong Kong, and so on. So you can you can look at those things. Yeah.
Thank you very much, sir, for rightly addressing the questions from a very broader perspective. The pioneering contribution on DR and DR antennas in your group. In fact, the early birth and also the growth of the technology involved in the initially directed the questions to Professor Siddiqui also enlightened on that, added on that. So coming back to the question, I just want to add that the BTech degree or UG degree can't be a barrier on the journey on anything, because if you see the engineers, even in ISRO or DR of the engineer, but done very pioneering work, very good work. They are mission director, group directors, and so on and so forth. As Professor Antar also mentioned, you need to understand the basics, the fundamentals, and from there you can proceed in any possible direction. So as I was mentioning during my part, I don't know whether I was properly audible or not, the connecting the basics with proper understanding through visualization of the modes, where you can deploy some of the knowledge and the tools to getting a deeper understanding, not just the mathematics, but the significance, probably, help the youngsters in a very much. And then with that also, you can have a very successful research journey. And as you know, in most of the academic institutions, even up PhD option is also there. So in that case, what happens is you have to have some extra courses in your PhD coursework. So that's why successful academic research as well as industry research, even with a UG qualification, simple bit having basic background and information. So I think this question is now well addressed. If other panelists wants to add anything, otherwise I'll move to another query.
I think you can move, because I understand there will be a lot of questions.
From Dr. Sarkar or Dr. Ghosh?
Yeah, can you hear me?
Yes. No, sir. Like, let's move to the next set of questions. I think.
Fine. Yeah. This is a very generic question, and for today's agenda, this is very important. I want to take this one first by Professor Antar sir, and then all of us can add on this. So, what are the prominent research problems and engineering these days? What are the broader perspective? What are the different areas and avenues for antenna engineering research?
Oh, you want me to talk about that?
Yeah, if you
How much time do I have? I'll just say one simple thing that somebody said in '87, one fellow IEEE, and his statement was, that's Walter Flood, late Walter Flood. He said, all the easy problems in electromagnetics have been solved. Okay. There is going to be a challenge. There's always going to be a challenge in terms of the new application that's coming out. Just think about it. 10, 15 years ago, we didn't have wireless. We didn't have all of these things. And now we're moving into the, wireless various applications. We're moving into Internet of Things, 5, 6G, moving up in frequencies and so on. And you need all the sensors for all of that. And for all of, we wouldn't be able to connect with each other now without antennas. So there's going to be demand. There's going to be antennas. Maxwell made his equations without a proof, and this was for a reason, because there is no proof for it. Application, life goes on. So there's going to be need for antennas for the various applications, biomedical applications, antennas inserted in the body. You need new materials for antennas. You need to know the interactive antennas. You need to deal with electromagnetic energy, as Debdeep was saying, and so on. So there is always going to be a challenge in new antennas to perform different functions and to be built using different techniques, different technology. So, as a young researcher, what would I do in all of this sea? I think I'll just take a side and focus on one application and try to look at an area that I can handle and work on. But in terms of problems, stay tuned to the AP Society. Look at the AP magazine, see the new areas, and see the education corner there, which actually offers quite a bit of new information and so on. And as you can see, the society keeps putting in features, special, special issues on this, on that. So the areas are tremendous, and they're going to keep changing and changing. And as I went through my career, in the beginning, we used to do analytical things. Now things are moving, and what I did 10 years ago or 15 years ago is now old stuff, and it keeps moving and moving on. And so I think you just stay tuned and look at the future applications, which guide actually what we do in our research.
Yes, I would like to take on from there, sir. Yes, I still remember just a few weeks back, Professor Antar handed me a journal magazine on application of AI and machine intelligence. That's how updated he is. He's always looking for new avenues and new research. So artificial intelligence and application of machine learning and technology, that's what this group is still looking into. So these are avenues, like you said, you can move on, move forward. And another interesting thing that Professor Antar said, that everything has been done in electromagnetics. in the same sense, like if you see the antennas we are using today, the Yagi antenna, still, yesterday we had Professor Mohanan's talk for the ST radar. We used an array of Yagi antennas. Most of the antenna work has been done. If you look Shelkunov's book, Shelkunov's antenna theory and practice, he even talks about the split ring resonator, which Pendry experimented and did in 1998. Like these things were already theoretically done in his book, in Shelkunov's book. Even Krauss, you can see the artificial dielectric, which has been taken from Shelkunov's book. The metamaterial concept, you just look up Ramu Winery, the fields and waves. You will find lots of theories which are applicable in today's date. So the technology is moving forward. We are progressing, but still the basic fundamental equations and the theories has already been done. If you do a good literature survey, you can always have a head start in this domain of technology. But like I said, things are moving very fast. It's just accelerating. And like Professor Antar, even like he has been a beacon, and he's always looking forward to new technologies and new ideas and how to motivate new researchers in this upcoming domains. And so, yeah, opportunities are just enormous.
Thank you very much, sir. So if I summarize in one sentence, it is like science clears the field on which technology is built. So if your basic is clear, if you have the idea, you can cope up with any type of research that is going to emerge, whether it is 4G, 5G, or MIMO, or any kind of new applications of dielectric antennas, or energy harvesting or wireless power transfer. Like for young stars, they want to hear some topics. So my suggestion for you is you just go to any of the premier AP conference or paper. If you go to that call for, you will see an array of topics, and on each of that array of topics there is a lot of ideas regarding what are the happening. But as Professor Antar said, and rightly supported by Professor Siddiqui, basics and fundamentals are the key point. If that is there, you can take up any kind of research problem, whether it is embedded antennas or biomedical applications or energy harvesting. Like that, I think Professor Siddiqui.
Yes, I want to add one thing which I find lacking. Even I learned it the hard way. When you start with the designing of an antenna, the frequency, the usable frequency, that's very important. What frequency we are working in, wherever we are living. Like that, we have the FCC controlling the frequency. They are the governing body in North America. We have the Wireless and Planning Commission. This usable frequency, we can design antenna any frequency, but is it usable? We have to have the understanding of applications for each frequency bands and ranges and the spectrum, and what is commercial and what is licensed and what is unlicensed. That is very important. That knowledge has to be there when you design a system. It's not linear, like you just cannot scale up and scale down in any frequency. So when you start a design, make sure that application, the frequency is well known and it's intended for the, it's whether it's commercial, whether it can be commercially used, whether it's licensed or it's unlicensed. That idea has to be there with the researcher whenever he starts a research in this domain. That's my
yes. As the MTT tagline says, that megahertz to terahertz, you have the opportunity to work the entire spectrum, but you have to see where is the level applications and which band, which type of applications you want to work on. So may I request Dr. Ghosh also to add on this?
I think, sir, already everyone is telling a very good points. So I think it's some more points discussion are there. Then I can put some lights on.
Yeah, can you hear me?
Yes, Dr. Sarkar, please go ahead.
Yeah. So I think the points that are already said by Professor Antar and Professor Siddiqui, and also you, like the way you summarized, I think it already covers almost the entire spectrum, like which kind of research topics that people should. And I think, yeah, the idea of going through the call for paper of any premier AP conference in order to understand the topics is important. And also another point is to, I think, to interact more with people from the real antenna industry, like who are involved with some, let's say, Qualcomm, or let's say, just I'm saying some names, and to read the like there are various articles that are available in the internet to showcase like what are the most upcoming developments or what new things. Sometimes that might be little bit promotional or little bit, you can say, that fancy, but if you have the proper penchant for the basics, then you can try to see through it, and you can try to see through the entire, like whatever marketing or marketing gimmick that there is there, so to understand what actually is happening. So that kind of insight, I think, that can only develop if the fundamentals are stressed upon in a proper way. So, and I think I should add that it is very important to relate the new, like let's say Maxwell's boundary condition, and how you can relate these to a radar engineering problem, or you can relate these to an antenna engineering problem. That vision should be there. The student should be guided in that way, so that they can also think in that manner. So that will be like a summary for the or a key way to solve the problems, like which are real life and which are for the future.
Right.
Yeah, that's the key, like getting proper guidance and proper motivation. So on this particular point, I just want to mention that many students nowadays, they start their which is typically on the 8th semester, but the smart students, they start working during 4th or 5th semester with a faculty mentor. And when I say mentor, it is not only the mentor in your institute. You can see and try to be in touch with some of the nearby institutes where they have good faculty and good researchers and good environment. So you can try to get some kind of boost at the very beginning, if you can get motivated and try to get associated with some problem. Regarding this, we have launched some kind of internship activities indirectly, and it is going on. And moreover, probably some of you must be knowing that DST and AICT, the two bodies of government of India, are trying to come up with different kind of internship opportunities for the students.
Yes, I think I would just interrupt you and add that I think IIT Kharagpur has also, like we are probably discussing on that, like they have this kind of DST funded internship program launched. And
it is there. It is that accelerated big gun scheme and some other schemes are there. So suggestion for the youngsters is you try to harvest some of those advantages, get tuned and try to get benefited through those initiatives, and of course through IEEE also probably we can try to have some kind of initiatives in the related direction. So the query which I want to initially to Dr. Ghosh, research opportunities regarding metamaterial absorbers in designing. Some other queries, how metamaterial antenna related projects are beneficial in future. So over to you, Dr. Ghosh.
Thank you, Professor Chinmoy sir. First point is that when you're talking about any of the metamaterial absorbers in antenna, so there are 2 points are related. Actually 3 points. One is the absorber, one is the antenna, and third one is the metamaterials. So you can play on the 3 topics, and in different way you can go on. So you can use the metamaterial absorber to improve the antenna performance by using one type of like artificial magnetic conductor, or you can use them to or zeroth order resonances particularly. So those things you can do for improving the antenna performance in other. Or on the other side, you can use those concepts particularly to use in types of the metamaterial in itself. You can use in the antenna geometry to use in the filter also. Like what is you can made about the filter plus antennas. So this is second aspect you can think of. Third aspect you can think of that there is a absorber concept also come up where you can concept is absorber plus filter. So there also you can use the absorber concept, and after that you can put it. And if you remember a few minutes back, Debdeep has told during his talk that not only the anti-jamming is not the only way to go for the research. Now try to combine everything, like try to combine starting from the designing, communication part. If you do everything and in a design, and you can make a complete research domain. So that means if what you are mostly doing is that We are mostly doing we are doing the antenna design, we just fabricate it, measure it, and we publish it. But how we are going to practically implement it, this antenna in the practical devices or microwave devices or in the communication devices? Have you do you know that how to install these devices in any of the MIMO devices, or particularly you are designing some MIMO devices or antennas, and how you are going to use this MIMO antenna in MIMO device for the channel cases? Therefore, the complete setup, starting from the designing to implementation, so that is also necessary if you want to go for any of the practical application. So same thing here also, metamaterial absorber. There are many people are designing. There are many papers have been reported based on the fabricated, and there is like a demonstration. But how many papers has come into the light of the commercial development? So if you can think of that, what are the practical challenges it is lying with the metamaterial absorbers, and how we are going to resolve this to make it in the in case or replace the conventional absorber. Like as for example, if you see that the normal pyramidal absorber, the commercial broadband absorbers, we are going to use it in any aircraft chambers or different places. Now we are talking about the metamaterial absorbers, but really at this current instant, the research, what we are going to do or what is happening in the metamaterial absorber, is it capable of replacing the pyramidal absorber? To be honest, no. Till now, the metamaterial absorber has to go a long way to replace this pyramidal absorber. So what are the current challenges? So if you can find the current challenges, and if you can resolve those current challenges, might you go for, you can go and you can talk to some industry, and you can make a small startup, or you can make a small company, you can open for the entrepreneurship, and you can go for the industrial approach, you can think of the research approach, and at the end you can work for a betterment of the technology, betterment for the everything, like society, scientific, social, economic, commercial purposes. About only the metamaterial absorber, I am talking about all of the things like antenna things also. So you have to think of that not only the problem, or not only in terms of the paper or publication. You have to think of that whether your work, whatever you are doing, it is really resolving the practical resolving the problems currently in the limitation mode, and how your design is going to resolve the actual problems which are facing in our real scenario. So those things you can think yourself, and maybe you can come up with some solutions. And at that time, if you can come up with one solution, maybe another person from another domain can come up with another solution, and you can combine with those things. Maybe you are coming up with a metamaterial absorber solution, how to make that absorber with minus 50 dB absorption bandwidth with huge amount of angular stability and for an entire broadband range. And now someone is coming up with a good antenna, or you can put this particular type of antennas, and you can going to use in a practical scenario. So now next part is that, so in this way, so suppose someone is planning to work in a conformal antenna, and in the conformal antenna, you have to place it in a conformal or non-planar environment, and you are going to use the absorber in some other cases where this antenna is like going to be behaved in a proper way. So those things you have to think of, that how you are going to place the antenna in a conformal geometry, how you are going to put an absorber in conformal geometry, and those practical things you have to think. It is not about only the papers, only have the how you are going to improve the technology, how you are going to like help the technology, your current your scenario to go for that, to solve the practical challenges. I hope that it's my
good. Good. You have nicely addressed this one. So Dr. Sarkar and Professor Siddiqui wants to add on this, because you have also worked on some metamaterial inspired antennas.
Yeah, I can probably add a little bit on that. Like two things. One is, I think that point is sometimes discussed a lot, like the metamaterial based antenna or this kind of thing. So, well, it is important to understand the physics, and when we are loading the antenna with a unit cell, it's probably not fair to call it a metamaterial antenna. But there are certain situations, like for example, the antenna is being loaded with a FSS kind of thing, and that FSS means it's basically a array of sub-wavelength unit cells, and it's probably you can say a variant of the reflect array concept, and we can use that thing to tune the beam. Like I think that is one of the key topics, like the antenna integrated with a frequency selective surface to get the beam forming. I think Dr. Ghosh also mentioned about this, like to get the proper beam forming. And right now many people in terms of the 6G, like this being branded as the 6G, that is this concept of intelligent reflecting surfaces, where you are using the this reconfigurable or tunable frequency selective structures along with some feeder antenna or along with a MIMO array. So these kind of topics can come up when I think the original question was to integrate the antenna research with the metamaterial kind of thing. So I think these could be some useful paradigms. And another, well, I missed one point because I worked on this during IIT Kanpur with some of the master students who were with my supervisor there. So that was mostly a very popular topic on use of this zeroth index metamaterials or these meta-surface lenses to enhance the antenna gain. So that is also, I think, a very key topic, because increasing the antenna gain in certain aperture array kind of environment, it is very challenging, and we need some low-cost radome kind of solution. So FSS-based radomes to increase the antenna gain, that is also another application that comes to my mind, and it can be branded as the. So, but eventually we have to think that when we are using metamaterials, it should not be that, okay, I just want to use metamaterials and I just want to use antennas and publish a paper. I think that was not the message that Dr. Ghosh also said. We have to think that whether it is leading to a low-cost solution, whether leading to a solution that is not possible by using conventional technology. So that insight should be there. That's what I would like to add on.
Yeah. So I guess the point both of you wanted to convey is, don't make the metamaterial meta, make it application oriented. And when you think of application oriented, the best impetus you can get is from the industry and the space agencies. They are thinking of a lot of applications of the gain enhancement and different kind of applications, radar absorbing materials and all. Of course, there are challenges, as Dr. Ghosh mentioned, but because challenges are that, that's why we are also there. So still it is open, but as Dr. Sarkar also mentioned, just putting few structures and resonators and calling them metamaterial is probably should be avoided, and better try to understand the physics and more with more specific focus towards the application.
Exactly, that is where our work probably we try to refute the term meta, because whenever we can talk about new materials like embedding just a splitting resonator on the surface on the substrate doesn't make it the metamaterial antenna. That's why I like the term metamaterial inspired antenna. Okay, that also makes sense, because we used either a splitting resonator.
Can you please mention Professor Mitra's comment regarding this metamaterial thing?
Yes, you have to a medium. It has to have an array of these materials to form it a medium. You just cannot use one single element and one single subwave resonator and call it a metamaterial, right? So it has to be a medium, and medium needs so this thousands of resonators designed in a perfect alignment in perfect shape. Then only it will form a medium, right? So like just extracting parameters from one single splitting resonator and calling it a metamaterial doesn't make sense at all. So that is where inspired. That's okay. That's still, so what is there in a name? Like people must understand that just the term metamaterial doesn't make the thing meta. So maybe we can call it new materials. We can talk about new materials and new year. That will be a new year of research in antennas, right? But still there are challenges, like using graphene-based antennas. There's challenges of the ohmic impedance, like impedance matching is a challenge. So these challenges will always be there. Like they said, the devil lies in the details. We can have ideas, but the devil lies in the details. That's what we have to solve, and we have to the challenge.
Right. With this, let us move to a next question. This one I directly beam towards Dr. Sarkar, because it's a very directive question, and you are working and you have worked on this particular field. So I basically combine two questions and you can come up in one shot. The first part is we are heavily depending on EM software for simulation and analysis. How can we get the more ideas on computational electromagnetic techniques? First part. Second part is how can I choose a specific topic in the field of MIMO antenna? What are the recent topics in MIMO antennas for current PhD students?
Yeah, okay. So yeah, I think this second part that was also raised yesterday, like during the inaugural ceremony or kind of thing. The first, I hope I am audible, right?
Yes.
Yeah, yeah. Okay, so actually I could not see you, so I thought that maybe I am having some connection issue. So the point is that this computational electromagnetics and the use of heavy dependence on EM software, I think I covered that somewhat elaborately during my like 5-minute deliberation. So again, I would like to repeat some of the key points from there that the EM softwares, like whether it's HFSS, whether it's CST, it's FICO or any other thing, you have to, like the students who are working on it should get an idea about the functionalities. That is true, like the how to operate the software. That is indeed a key point. But not only that, it is important to understand the algorithm that is behind it, right? So the algorithms regarding that, there are several, like finite element method, FDTD method, or it could be the method of moments. So if you understand the electromagnetic algorithms correctly, then you will be in a better position to interpret the results and to like properly design the antennas in the long run. So that part I like highlighted, and also I emphasized upon the importance of developing own codes. Like it sometimes gives you a further insight and it can help you in designing the systems in a better way. Like the way you can write your own FDTD code, you can write your own MOM code. And in fact, some of the research problems also require the writing of customized codes because of the problem geometry that might not be, like it might not be possible to realize that in a so-called commercial software, like the memory requirements or the system can be. So you may have to go into the integral equation, may have to dig deep into the Green's functions, and then you can have an idea, or you can write. I remember one of the talks by Professor Gautam Chattopadhyay. He was mentioning the design of a particular slot array that is used in a NASA rover kind of application. So that slot array, it was a very complicated looking structure. And what he mentioned, I still remember that point, that it's not possible to design that kind of slot array in a so-called HFSS or a so-called CST, even with the present advanced thing that we are having. It's still not possible. So the postdoc who worked on that problem had to develop his own code and get through the entire thing. So that is the importance of understanding computational electromagnetics is very much there. And regarding the modern day antenna solution problems, it is there. Now I'll come to the second point that you mentioned regarding the MIMO antennas. Well, as you know that when we are moving from this 4G to 5G and later on, so there is this challenge, like I often talk about this during the various. Am I audible?
Yes, you are, please.
Yeah, okay. I think I thought that there was some issue. So I think I mentioned this point a lot of times during various webinars, that it is important to go through this multiple antenna technology because of the constraints that are there on the bandwidth as well as the transmit or receive power. So since we are looking into building up more and more wireless devices, that's where the industry is pushing us to, and also the demand for the high data rate is pushing us towards. So it is very important to understand that being a like a single antenna designing kind of engineer, it's not going to work for a long time. We have to think about using multiple antenna systems in the long run for the industry oriented projects. Now to select a problem on the MIMO antenna. So I would share my experience. Like initially when I started working during my PhD, when my advisor told me to dig deep into that topic, there was a more push towards developing the integrated 4G, 5G antennas. And we used to develop this multiple, like say 4-element antenna systems or the stuff that can be integrated into the cell phone or the portable handsets. So that those designs had their unique challenges. But now the focus has gradually shifted more towards the base station. So I think for any student who is trying to go through the initiation of his PhD or initiation of his research problem, it is better to move or push towards like this massive MIMO kind of systems. I would say that because of the present trend, it might change a few years later, but presently there is the push towards the massive MIMO and the realization of antenna systems that has the more than 100. Because some people, I have experienced this, some people have this confusion. People often use the 8-element antenna system and term it as the massive MIMO array. So that is not the correct way to describe it. Massive MIMO is basically for the like this base station kind of application. So I would suggest that is one key topic in terms of the design, if you can say. And secondly, another important part is regarding the analysis and whether we have the correct algorithms to predict the channel capacity, to predict the antenna correlation, and various kind of this inter-antenna or inter-element interaction. So regarding that, I would like to point out that during my association with Professor Antar in Royal Military College, Canada, I was fortunate enough to be exposed to various new current green function based algorithms, antenna current green function, as well as the cross correlation green function based algorithms that were developed by earlier researchers. And those algorithms give you some further insight into the or integrate towards the communication channel as well as the like antenna part. So that kind of algorithms where you can use your electromagnetic knowledge, your knowledge from the antenna interaction, your knowledge from basic electromagnetics and the like infinitesimal dipole modeling theory, that will come in handy to predict the larger aspects. Because in simple, I am digressing towards more technical term, just to simply illustrate the problem. That suppose you are doing a channel measurement in a particular indoor room and you are getting some results, but now to interpret that result, you have to model the antenna properties like the pattern, like the polarization, and how the mutual coupling of the antenna is actually affecting the channel capacity, the data that you are getting. So you cannot build better antenna systems or effective, efficient antenna systems unless you properly address the antenna interaction itself. So you might get some suboptimal performance. You might look for a certain data rate and you might come up with something else. And you can think that, okay, probably something happened. But what actually happened and whether you can improve on that. So to do that, it is very important to integrate this MIMO antenna or MIMO channel modeling kind of research with the, you can say, antenna computational electromagnetics also, as well as the analytical part also. So yeah, I would probably end there and wait for more feedback. And
you have very nicely addressed the question. That's why I mentioned that the question is focused towards you. But of course, other panel members can add. I just want to mention that as Dr. Sarkar highlighted, the communication aspect of the MIMO antenna and its application, that aspect also needs to be addressed, because ultimately it's a communication technology. Antenna is one perspective, but other perspective from the modulation schemes, bit error rate, and so on and so forth, data rates, etc. So from that communication perspective can be added up together. Then probably research will be more tangible. So these are some directions. And another very crisp answer to that last question is write email to Dr. Sarkar to get more exposure on this kind of queries, right? Yeah. So anyone else wants to add on this?
Hello, Dr. Chinmoy.
Yeah,
Yes,
please go ahead, sir.
Another aspect is to be aware of the policy changes. The GSM band, like with the 5G coming in, within 2-3 years, this is going to change the frequency spectrum. The voice communication is going to the 3300 megahertz. So that is 3.3 giga to 3.5 gig. So, and like this LTE terminology, this is going to change. So be aware of what frequencies will be used for 5G and 6G. So this, whenever you design a system, you have to be aware of what frequency you're designing for, right? Because it's intended for a certain narrow band. So be aware, things are changing very fast.
Right. Excellent. Yeah, in fact, it is very nice that you added this part, because there is a misconception that people, whenever they are thinking of the 5G and all, they are always thinking that it is millimeter wave band, which is not always the case. There are
There's a
even
Yeah.
sub 1 gigahertz, sub 6 gigahertz band, and so on and so forth.
Yeah, it is very important to look into, just to interrupt and add, like the point of the frequency region. It is very important to look into from Indian perspective. The Department of Telecommunication and from Government of India always updates like that part, and there are several white papers and the reports regarding the this wireless bands and which band are used for which kind of application, like regarding the short range radio, which bands are used, regarding the 5G, which bands are currently, like, the Government of India is focusing on. So just to add a bit more context to that, like that sub 6 gigahertz band, as you rightly mentioned, that is in focus. There are also these 28 gigahertz, 38 gigahertz bands, and this might change, as Professor Siddiqui mentioned. People can come up. So as an engineer, it is not always in our hand to devise the policies, but we have to be aware of it, and we have to know that which frequency range we have to design our antenna system.
Right. That's the point we always tell in different fora when we present technically or we talk and interact with the youngsters, that the broader picture should be known. Even if you, when as a starter, you may be working on metamaterial, on some antennas, small antennas, on some polarizer or some, ultra wideband antennas and all. But don't just focus in a very narrowed manner. You should know the broader perspective, like where is this going to be applied, and what are the other peripherals, other subcomponents that comes along with this. Then only the research will be more tangible.
Yes, true.
Yeah. So with this, there is a question which is previously accepted question, and there is one more similar question in the chat box. So I'll combine these two questions. First, let me read out. It's identical, so I'll modify it accordingly. How can we improve the connectivity issues in remote areas where network connection is really low, especially in this current scenario of COVID-19? And the second question on the chat box is also similar, like how during this pandemic situation the research, academics, and all these things can be continued. So because I know Professor Siddiqui had a very successful project from IEEE site on remote diagnosis for medical applications, but it is also something similar because it is related to connectivity issue. So I direct this question to Professor Siddiqui. Yes, sir, please.
Yeah, connectivity issue, like, well, you can't help much, right? Because remote areas, we have the base station. When I did my project, I was using the internet.
Yeah, maybe you can initially brief regarding your project little bit, then you may address focused towards this question.
Yeah, I won't take much time, but the project was, how to get, using the IoT, the Internet of Things was there. So this concept using the available internet, like I was in a village and that village never had any kind of connectivity except the internet connectivity. It was a very remote village, but you had the internet. So why not use the internet to send? So I used an electronic stethoscope to get the lung auscultation data and transfer the data to the computer, and use the mobile phone to connect to the doctor in the city, and through the internet send that data to the doctor, who could hear the lung auscultation, from the stethoscope in Kolkata, and while I was in a village in Mushkabad. But this kind of connectivity issues has always been challenging in different terrains, like in tribal regions, in the hilly region. The technology, that's why we use this microwave technology, microwave RF transmitters and receivers for signaling system. The railways have always used it, and where the terrain was not that bad, people use optical fibers, because fiber technology is obviously that's green technology and that will give you the best bandwidth. But wherever it's not, where it's impossible to have those kind of laying cables and all, you go for this wireless transmission, wireless antennas and towers. You can you have a direct communication link. You have to decide the link. So these are challenges will always be there. Now what I'm thinking, came to my idea, an idea, like in flooded region, when there's absolutely no communication, the base station goes down. How can you communicate? Now, I found out that drone technology is coming up. There's drones now, the technology, we have drones available everywhere. There are small commercially available base stations pertaining to GSM frequencies. Maybe you can use that technology, placing a base station on a drone and flying that drone in that flooded area. That can restore connectivity some few hours, depending on the battery of the drone, how much it can run in that area. These kind of ideas can come up, can be floated. Like ham radio. Now ham radio is now replaced by a software-defined radio, so that's dying. That technology is dying. So it has always been helpful for in remote areas during the natural disasters, calamities. That has saved lives. So now I'm thinking with this new technology, new ideas coming in with drone and this portable base stations, that can also be used and thought about of restoring connectivity in demand in very calamitic situations. So yes, like you have to brainstorm ideas, and there would be, definitely humans would come up with different ideas for each situations.
Yeah, excellent. Very nicely addressed, sir. Just I want to add and remind the participants that this virtual meeting that we are having now, that is, because of the lesson that we have got during the pandemic, right? So
Right.
pandemic, disaster or whatever has never stopped the human civilization and the human mankind, because combat these, and we have always come up with the better solutions, because now all these virtual classes, even for school kids, to high-end meetings for UG, PG and all level research discussions with the research scholars and the faculty members, all these things are happening in a different way. Of course, there are certain limitations which cannot be done, especially the experimental front and all, but then we have got a new we have adjusted to the new normal, and we have come up with some solutions, and now people are thinking of the hybrid mode. So even if the normal situation comes back, so we'll have this kind of virtual mixing of the physical and virtual situation to come up with a better response, better education and all. Like I just want to add, like so many Zoom lectures and so many, even the labs also sometimes we are doing in this virtual mode. So even if during this pandemic we are not stopped, we are doing the thing in a proper fashion, and then probably the research also can happen. Maybe the experimental part will be waiting for the time being, but we can definitely have the basic research, the theoretical thing and simulation and those part keep continued, right?
Yes.
So anyone else want to add on this?
Well, I think Dr. Jawad has already covered all that thing, and you have also summarized it. So yeah, we had regarding this online meeting, I would reiterate some of the words that Dr. Jawad says in other forums also. We had the technology with us, but we did not apply it to this effectively until we where we were faced with this kind of a hard situation regarding the pandemic. And regarding the labs being held remotely, I think there were some of the newspaper articles and some things, some of the more sophisticated labs, they have the equipment for getting connected to the internet and doing some kind of experiment or measurement out of that. So once we involve that kind of high data rate and stable, robust connectivity, of course, you have to ensure the basics like electricity and all those things should be there. Upon that, you can build some kind of connectivity so that even some experiments can be done, like 1 or 2 personnel can be there in the lab with proper social distancing and all, and other people can use the internet to get connected. So some kind of thing, I am sure people will be working on that, and there will be some solutions that will be coming up on this front, because as you mentioned, human civilization does not stop whenever it's faced with some kind of hard situation, it tries to struggle and overcome through it. So I hope and I sincerely believe that that will happen in this scenario also. Yes.
Dr. Ghosh, would you like to add on this regarding your experience on teaching and research during this pandemic situation?
Yes, sir, Professor. Thank you, sir. Actually, everything has been already been covered by Professor Javed sir, Dr. Debdeep, and you. So just one thing is that although the pandemic,
Because
of course,
one
is
thing I have seen,
facing
you are using that digital board very effectively, very nicely.
yes, yes. So that's why I'm trying to say that try to implement the absorb technology what is coming to this pandemic. Every situation has some bad aspect, like some negative aspect, some positive aspect. Here the pandemic is like teaching us that how to absorb the new technologies, how to become new normal, etc. So now, as an academician, you can say that we are like trying to learn how to teach the students in online, how to take the quiz online, how to take the how to evaluate the students in online, etc. At the same time, the students they are also trying to learn that in which way they can study to online mode or they are going to do the research online mode. I don't think that this is for the temporary cases. Even the pandemic is going soon, maybe within 1 year or maybe 6 months. This system is going to be new normal. Most of the online webinars will be going to be online to reduce the cost cutting or something. Most of the teaching will be go online, and there will be many things will come which will be utilizing this technology in the coming days. So it's better always try to absorb that technology in a positive side and try to learn the what is the technology giving. Okay, so that is my. So don't think it is a negative side instead of taking the positive side and try to. So obviously, it is very difficult to stay positive in this situation, but try to stay positive and try to
Yeah.
see that what are the things are coming with this pandemic.
Yeah, I think we can close this question because it is very
Hmm.
nicely addressed by all of us. So only the
Yeah.
last summary of this point is, the when the entire world was talking about break the chain, we wanted to say make the chain and keep the chain, make the chain and keep the chain. That is the academic chain, right? So this pandemic hasn't really affected us on that front. We have shown from academic fronts. I mean, the medical friends and all, they are also showing from medical fronts. And of course, in as Professor Antar also mentioned, that every one member out of 10 members of APS is from India, and similarly, every one out of 6 across the globe is an Indian. So that is our strength, and sometimes that is our weakness also. But I really like the statement that if you have a half glass water, don't think it is half glass. You should think half of water and then half of air, right? So always we have to think in a positive perspective, and then we'll always have a better solution with any kind of given situation. So the questions which are received uh, previously is somewhat close. So I'll take a couple of questions from the chat box now, and then we can probably conclude the session. So one question is regarding these startup initiatives from Indian perspective. So probably I would sorry request Professor Siddiqui to take this one first, because he has already replied in chat box. Maybe he can elaborate on that.
Yes,
Yes,
TechKeep
please.
TechKeep provides opportunity. Like there are lots of technical universities in India, who has this TechKeep program running in, and this TechKeep program has startup opportunities and startup cells. So, but they're not being explored. I haven't seen, too much of exploration of in that front by faculty members, neither by faculty members nor by students. So they can take that opportunity and talk to their, like startup cells in the institutes, and most of the institutes will have that.
So
And
for
they
that,
can
the
start.
market potential is very important. So what is your call on that? Like startup will sustain. Of course, many institutes are coming up with their incubation center
Well,
also.
there's a challenge. Only 50% of startups sustain. It's sustainable. It's not sustainable. Sustenance is not easy. But then you can't lose hope, right?
Yes,
Yeah.
that's what I'm like. I mean, with your experience and expertise with
Like,
carrying industry research,
yeah,
so like
yeah,
how to have a
the
market survey
sustenance
and
low is very low, but still that shouldn't stop someone from starting it, right? So,
yeah.
never lose hope. Yours might work. One in 7 works. So you might be the lucky one. So it depends on dedication and and how much integrity is there to take it up or follow up. So if the persistence is there, perseverance is there, idea is there, it should work. And there are also lots of joint, like venture capitalists who are willing to invest in ideas. That can also be explored. Venture capitalism in the North America is very robust. In India also we have opportunities. We can talk to venture capitalists. They can click on an idea. Like Loan Shark is a very interesting episode that goes on where they invite ideas from anyone, and if somebody is interested to invest on it, do it. So opportunities, it has to be explored, and I think the institute will give you very good information if they have the startup cell. It's a TAKIP mandate to have startup cells in most institutes who have this program. So explore that. I would request the students to explore that every day.
Yeah, very nicely addressed again by you, sir. So I know our current chapter chair of APS Kerala, Professor Abdullah, has been involved as the director of the incubation center of Cochin University. Maybe I'm using a wrong term, but he was at the helm of that affairs, that industry academia initiative. So are you there, Professor Abdullah? Can you enlighten us on that? Okay, so probably he's not there. So I'll just add one point, like many of the institute nowadays are having their incubation centers, and the basic idea is to help the students, those who are really want to come up with some startup ideas on the administrative front, on various things. I mean, the infrastructures, the basic electrical infrastructure, space, and all these things, which is a big problem to even think of at the beginners level at your early career. So Indian institutes are coming up on this thing. So I think, as Professor Siddiqui said, that you have to have the venture, then only you can think of a success. And just I want to mention, it's like a marathon race. So some people will be running for 100-meter with a very high momentum, but those who wants to have their own company and all, so they have to think in that fashion. So you might not have initial momentum, but at the long run you will be the winner. So I just want to share my experience. Like, I have seen some of the students who are not the so-called fast bencher or academically excellent. I mean, most of the time, most of them come up with this kind of ideas. So maybe initially sometime they are kind of depressed and all, but finally they come up with this kind of thing, and many cases those has been successful. So
Chinmoy,
anyone
like
else wants
out
to
of
add?
the box.
Yeah.
It's like thinking out of the box.
Yes. So one more. Yeah, so there is a new interesting question in the chat box. I guess it's so this TAKIP. Okay, this was addressed by you, sir. So there is a kind of technical question rather on ECC calculation. Probably I advise you.
I can see that. Yes.
Probably you can have a very crisp answer now, and he can probably contact or talk to you.
Yeah, I think the ECC calculation feature has been added to almost all the commercial solvers now, like in HFSS and CST, and it is possible to write one's own codes and macros to integrate with that to calculate the ECC. So simulator wise, it's not a problem, and well, it is possible to get the radiation pattern from the EM simulators, like say the CST or HFSS, and get those patterns into MATLAB or even some other language, some other open source thing, and calculate the ECC. So there are various ways to do that, and the technical aspect I will not go into too much deep, but I hope I have covered like the various approaches that are taken by
Yes.
And I can also see another question: when will 5G be available in India?
Yeah.
So anyone wants to take that?
You may first start.
So, well, I think the 5G thing, the way we are looking into commercial deployment of 5G, there are some of the reports by Qualcomm and other group who have done some work on this 28 gigahertz module and the sub-6 gigahertz module. To know more about the 5G in Indian perspective, I would suggest to go into the 5G initiative web page. I think IIT Madras and IISc Bangalore and other leading IITs, they are combining to this large project, and in which various groups, various researchers from other background, communication background, like they are addressing several problems. So it is very and also IISc Bangalore in its last technology day or something, they have reported some of the like initial experimental validations of this 28 gigahertz MIMO technology, and there are also works going on in the sub-6. So if we want to like be independent and self-dependent regarding the 5G, we have to like work more towards this 5G initiative, and we should see like the people who are in various other institutes, they can see that how they can contribute to that. Only when we join hands, we can make the 5G initiative successful and bring it in a proper particular direction from Indian way.
Just
so I do not have the exact year to say, but hopefully it should be so. Yeah.
Right, because it is at the hand of the policymaker and also with the government. So we can.
As far as I know, that Vodafone is going to switch to full 5G by 2023, and they're going to release that GSM band.
Right.
That's the information that's by the private operator.
Right. But it is also linked with the government's approval and other aspects.
They know the approval, so they are switching. They are slowly trying, like moving on with that.
Right. So right, just one more point I want to add on this. Very recently, there was a 5G World Forum at Bangalore. That's IEEE 5G initiative. So there were very good speaker panel members and invited talks. And we also had a paper from our group with all of us as the authors there. So probably those forum is still open, and without any financial implication, you can probably download some of those papers and see the initiatives, and even the invited talks are also open. So you can probably look into that to harvest more information on this particular thing. So with this, we have covered almost all the questions from the chat box. We did not select each and every one because those are linked. We have covered almost everything from the questions which are taken a priori, and also we have covered the chat box. So now we can take a couple of open questions, and then probably we'll go for the conclusion.
Is Professor Antar there?
Sir?
Professor? I have a question for Professor Antar.
Yes, please. Professor Antar, are you there, sir?
Yes, I am.
Sir, there is a question by, no, it's not here in the chat box, but somebody is writing to me like regarding the publication charges. Is APS considering any reduction in publication charges in AWPL journal or A4 because the charge is too high, or even in Access, because the charges are too high for academicians from our region, from this part of the world. So is there any thought on that? You can shed some light on that?
Well, it's high for everybody, actually, everywhere in the world. But I think this is an IEEE policy, not APS policy. So right. I think we can look at that. I'm not up to date on what the IEEE is or gonna be looking at in view of the present situation. But I really don't have any real update on whether they're gonna, reduce it or anything like that. But it is a problem. I acknowledge that for everybody.
Right, sir. Right. So, okay. Thank you, sir. Thank you so much.
Yeah. From the audience side, we can take one more open question. Anyone can unmute and ask.
Sir, I have one sir silly technical question, sir. It really confused me many times. Like, is there any difference between the antenna gain and the directive gain, or is these both things the same, sir?
I think Dr. Saha, you can take that up.
Yeah, see the directivity and the gain, these are the very basic thing. Probably you can go into the basics and you can see that particular part. So one is in terms of the power that is accepted by the antenna, and one is in terms of the power input to the antenna, that is applied to the antenna. So there is a difference because of the reflection loss factor which is coming into picture. So as far as the IEEE definitions are concerned, antenna is not responsible if antenna is not receiving the full power, because it is the connector's responsibility also to ensure that the full power is accepted by the antenna, then it radiates. So that's the key point. Like if you consider the reflection loss, and then then you define it as a gain in terms of the power accepted by the antenna, and then you define with respect to the isotropic radiated power. But in the other case, you call it the directivity. So I think this is very fundamental. You can go into the details later on. If others wants to address on this, it's okay. Otherwise, probably we'll move on to something.
Better to move on to some other question. Yeah.
Anyone else?
And what is the rule? What is the rule of thumb for like antenna gain value? Like for return loss, we have like 10 dB value. And what is the value for gain?
Yeah. It's the first of all, for youngsters, and some people even confuse the antenna gain with the circuit or amplifier's gain. So it is the directive gain. It's not like we always ask this type of questions in the Viva board and other places. So it is with respect to the isotropic radiator. So gain can vary depending on the situation. Sometimes even for some antennas, negative gains are accepted for some of the applications because efficiencies are very less. But then there are very high gain antennas, some array applications, space applications, especially for satellite tracking kind of applications. You might expect for a gain as high as 20, 30, even 40 dBi. But one antenna cannot satisfy that. That's why you make an array, and or you use a horn, and on the feed antenna like parabolic reflector and all. So it's a very broad. Your question is unfortunately.
Yeah, I think I would take a little bit on that, like on that question. Like as he mentioned, I think the thought process is not. We cannot deny it. Like sometimes people think that okay, S11 is like it should be minus 10 dB or something, but that is the way the power is paid into the antenna, and how much the antenna is receiving, and how much it is getting reflected back. But for the gain, you have to think again in terms of the physical works, whether you want to illuminate a broader area.
Basically, how you want.
Yeah,
you want
it entirely
radiation, or you want a direct
focused. So when you make it focused, again you will need the higher gain. So for those applications, if you want to illuminate a broader area, you want to take signal from all the direction, you want to make it close to isotropic. So antenna gain, as Professor Saha also mentioned, it is not like the amplifier gain, and you have to. It entirely depends on the application. That's
If you are having a mobile receiver, you want to receive from all directions. So then you don't really need a focused beam. So there you don't really require a high gain. But if you want to have a pencil beam for a satellite communication, then you really need a very, very high gain. So that's why I said your question is not having a crisp answer. So it depends on the applications.
Yes.
It depends on the application. Your S11 might be just 3 dB, minus 3 dB, but still your gain can be very high if it's a directive antenna, right? So it's not a power gain, it's just with respect to an isotropic radiator.
How the energy is distributed in the space, like
exactly. So
please go ahead.
One is just theoretical, just like a ball, right? And you have enough air inside the ball, a balloon. So if you compress that balloon, that air is directed towards one particular direction. That is basically the gain. It's just finite. You are basically having sensors finite amount of power in one particular direction. This can be a one maximum direction, which would give a very good directivity, or can be compressed, can be omnidirectional. So isotropic radiator is a very ideal condition, which is hypothetical. So we take the gain from there, how much extension of power is there in one particular direction or in one particular plane.
Yes. And just to summarize your question, that it's a good question, of course. We never discourage any question. So for S11, there is a benchmark because you want that some basic amount of coupling from the feed line to the antenna. That's why you have at least minus 10 dB or VSWR nearly equals to 2, right? But in this case, because you want what type of radiation, based on that you have you get the gain. That's why S11 is clearly benchmarked but this one is not clearly benchmarked.
And
That's the
that's what
bottom line.
antenna is known as a matched load, right? Because impedance matching is very important. Whatever connector you're using, cable you're using, it depends on eventually the matching.
Yeah. Because without this matching, the second part will not come into picture. So
Yes,
that is
yes.
the clear benchmark is there.
Efficient transfer of power from one medium to another medium. That's it.
Right. So
Yeah.
I think with this, we are at the fag end. In fact, we have exceeded our timeline. It was probably
Yes.
very effective discussion. So may I request first Professor Antar sir to have a concluding remark from your side, sir, and also
Well, I think
your
that's
wishes
it.
for the future journey.
Yeah, I guess you all want to go for dinner now, and I want to go for breakfast too. But it has been very, very informative, very effective, and I thank all of you for arranging that, and I thank the participants for holding on that, and it was great. So thanks very much, and all the best to everybody.
Yes, sir.
Thank you.
Region 10,
we
we
have
are
a
really grateful and gracious for your gracious presence for so long. You still haven't had your breakfast. But thank you so
We'll take care of that, but thanks very much.
Thank you so much, sir. Thank you so much.
Thank you very
You
much,
blessed
sir.
us so much with your presence. Thank you so much,
Yeah.
sir.
Sir, I was thinking of we can take a photo because this was such a fruitful discussion, and it will be nice if we
Please
have a
do
group
that.
photo.
Please do that.
Okay. Can everyone
Yeah, so
open the cams?
I think Jawad sir is visible. Dr. Ghosh, are you there?
Am I visible?
You are
Yes,
visible to me.
it's visible.
Jawad sir is
Because
also visible.
I was having horrible time for in between. No.
Samtar,
Professor Antar,
Sir.
Am I visible? I think something
No.
is.
yes, something is amiss.
Yeah, something
I
is.
can see. Yeah,
I need
can see.
I need a metamaterial in my computer here.
Yes.
Yeah, so I'll just take a rain check on that.
Yeah.
Right, sir. We will do some photoshopping probably. Yes.
Yeah, but don't use the anger ones. So.
I have taken the screenshot at different points, so I can maybe edit in the cams. So
Yeah.
it will be all right.
Okay.
Yeah, please do that.
Yes.
And please share the photos with us too.
Sure, sir. We'll do that.
And let us know when is it done.
Yes, sir. Yeah, the photo has been taken, so we can move on.
Yeah, right. We don't have to say cheese now, right?
I request Professor Siddiqui to conclude by just bulleted points or so.
Oh no, thank you very much. It was a very informative forum, and I think it's one of first of its kind, specifically on this domain of antennas and propagation. But it's a fantastic initiative. Like I said initially, I mean, if we can have something of a handshaking mode, if other chapters can chip in and learn from this experience, this hybrid mode is going to stay like it's going to be the new normal. But it helps to connect everyone, from any part of the world. It's not limited to this Kerala section. I'm sure there are participants from other sections too, other chapters too, in India and can be abroad. So this kind of initiative should be shared with other chapter members in other parts of India. And thank you so much. Keep up the good work. Keep up the good work. Thank you so much. It has been a wonderful journey.
Thank you very much.
Thank you. Thank you.
Thank you very much, sir. Dr. Ghosh,
just another word, like Professor Anta said, if you can have a write-up for the magazine, that would be very beneficial. It can go to the mass.
Yeah, yeah. I think student will take initiative on that and will guide them towards that.
Yeah.
That would be very fantastic. In fact, if it goes to them, I think that, yeah, one kind of unique achievement. So
Yes.
I want the other panel
I think
members
you
to
should
have a
push
final
towards
say.
that because it deserves that. Yeah.
Yeah, definitely.
I think
Dr.
it would be
Ghosh?
good to do it very quickly because this is a very quick initiative, and you should get credit for that because other chapters would follow.
Yes, sir.
Right, sir. Thank you very much, sir.
Yes.
Okay. Thanks for everybody.
Thank you,
Yeah.
sir. Thank you,
Yeah.
sir.
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Thank you very much.
Thank you.
Want to conclude on something?
Yeah, I think I would also say the same. Like it has been a unique
30 seconds.
experience and like very what should I say, enriching for all of us maybe to interact and to come up with the new ideas, what people are thinking, and how we can actually solve what they are thinking, and we can add on that. So it's been fruitful, and I am happy to share my thoughts and whatever experience I have with the students. And I also learned a lot from the other fellow panel members and who have presented or illuminated in various directions. So yeah, this kind of I would like to conclude on there, and looking forward for such initiatives. It might be taken up by other chapters, other forums. People will be benefited because apart from the webinars, conventional webinar, this could be like this kind of panel discussions could be more illuminating in a way for the students or for
Right.
the youngsters.
Right, right. In fact, I just want to say, like in conferences, also students don't. Most of the time, they don't get this kind of opportunity. They
Yes, yes.
just hear the paper, and then you don't really get opportunity to interact or ask a basic question, which probably happened today. So,
Yes.
Dr. Ghosh, you want to conclude in 30 seconds?
Yes. Thank you, Professor Chinmoy, also the organizer, for arranging such a wonderful session. Along with all the, I hope that all the participants from the various part of the country are greatly benefited. Another thing is that this practice is a very good practice, and maybe other chapters they can think of that and they can extend that type of practice also. Maybe in the other other parts they can think of that they can choose some dedicated topics, and they can choose the dedicated topic to discuss for the open forum. They can invite some particular faculties, renowned faculties on that topic, and they can create this type open forum for 1 hour or 1.5 hour in that case. And maybe similar to these things, similar to this arrangement, they can also invite some questions so that the dignitaries can respond them in a very good way, and it will be helpful to all the students. At the end, it is for the student and of the student. Okay, and it should be done properly.
Thank you very much. Thank you very much. Yeah,
Yes,
thank you.
The biggest achievement is to have the AKAPSSC presidency for 3 hours, and that's fantastic.
Yeah.
Right. That we are probably luckiest and probably one of the most unique initiative by the All Kerala IPS student branch chapter chairs. So they are it is their program. So we have all helped them, and they are really, many of them interact with me personally. So they are in the probably seventh heaven when they came to know that Professor Antar will be there in the panel and in the program also. With this, we come to the conclusion of this panel. So I think everyone have been very generous. All the questions have been very nicely addressed, and it was, in fact, a fruitful discussion and roadmaps towards the successful research journey and the milestones. Probably you have got many ideas and certain doubts and also being cleared. So with this, we conclude this particular panel discussion with sincere thanks to Professor Yahya Antar, who is a real mentor, leader, and legend in our field, and also to Professor Siddiqui for nice deliberation from different perspective, from industry to academia to pandemic situational, to Dr. Saptarshi Ghosh for his nice deliberations on some of the stuff, especially the observer, its applications, and how to make a successful research journey, to Dr. Debdeep Sarkar as well, because he has talked very nicely regarding the combining some of the simulation, obstacle, and how the computational electromagnetics and its learning can be deployed for solving some of the problems. And I hope we have covered the things very nicely. And with this, we conclude this panel discussion. And over to the organizers. Thank you very much, everyone. Thank you very much, sir. All of you. Thank you very much.
Thank you too, Chinmoy. Thank you very much, Chinmoy. Too. So thank yourself.
Thank you, sir. Thank you, sir. Yeah.
Thank you, Professor.
Thank you, sir.
Yes, sir. It was very good having you all for the panel discussion. It was very fruitful, and I believe that all the students present here really benefited from this discussion. And it was very good to have Professor Yahya Antar sir here. And we never expected that you would spend so much time with us. We are so happy with that. And I'm grateful to Javad sir, Debdeep sir. I'm also grateful to S. Ghosh sir and also to Chinmoy sir for handling and moderating the session. Thank you all. Thank you very much.
Thank you.
Thank you.
Thank you.
Have
Good
a
night,
good
and good day to Professor Antar sir and Javad sir. Thank you very much. Bye.
Good night.
Thank you.
Bye.
Yeah. Bye, everyone. Bye.
See, Professor Raghavan is there, I believe.
Yeah. With this, we come to the conclusion, and yeah.
Yeah. So I'm leaving, sir. Yeah.
Yes. Yes.
Okay.
Bye.
Bye.
Thanks.
Bye. See you later. Yeah.
You may please conclude them.
So we are ending day 2 All Kerala IPS Student Conclave. So we can see tomorrow 7 p.m. IIST.
Thank you.
Thank you.